Okay, good morning, all of you.
Good morning, sir.
Today, the last day of the program, which is we have conducted since 1 week, that is recent advances in automotive technology. So today we have with us Dr. C.S. Reddy, who is going to deliver lecture on the topic materials for automotive applications. Okay. Before he is going to deliver lecture on his topic, I just want to give brief introduction about him, what he is having the expertise, and what he is going to deliver the lecture for this short-term course. In fact, he's having three papers of biodata. I'll just go through glance, I give a glance of just biodata, his experience.
Okay.
He has done BTech from Punjab Engineering College in 1988. Then he has completed his master program mechanical engineering from our institute at National Institute of Technical Features Training and Research in the year of 2000. Then he started initially his working in Punjab Tractors Limited in 1988. Thereafter again next he shifted to Eicher Tractors Limited, then New Holland Tractors Limited, then Brahma Stair Tractors Limited. Thereafter again he changed, that is Punjab Tractors Limited. Greaves Cotton Limited, Aurangabad, then Agri King Tractors Equipment Private Limited, Chandigarh. Then he worked as a general manager in R&D in Mahindra and Mahindra Swaraj division in the year of 2012. Then he worked in ACE Faridabad as an assistant vice president research and development. Now presently he is working in Continental Engines Limited as an assistant vice president and R&D department. Okay. Now he is having expertise in this automotive tractors and engines, and he is having expertise in the area of this ARAI, ICAT, that is CFM, TTI. Okay. So now I request Dr. P.S. Reddy to deliver his lecture on materials applications for the automotive technology. Please.
Thank you, Dr. Rao. Good morning to participants here in the studio and all the participants who are at remote locations. This seminar is for the recent advances in automotive technology. The topic which I am going to cover is little different, but it is a compilation of the materials what in the automobile industry or the engine industry we are currently using. It will cover the steel, the cast irons, the aluminium, and to some extent the plastics and the polymers available. And even later on, you can use this presentation for your reference while you are selecting materials, while you are doing your design activities or your research activities in your colleges or even the industry wherever you work later. So it can be a handy guide to all of you. Can you have a pointer?
सर माउस यूज कर लीजिए सेंटर्स को नहीं दिखेगा सर पॉइंटर से सेंटर्स को नहीं विजिबल होगा ना इन्हीं को विजिबल होगा अगर माउस से करेंगे तो सेंटर्स को भी विजिबल
So you could read down. So the material, what material to be used for a component or the different components in aggregate, the selection of material to be used, it depends upon three criteria. One is the function, the part which is the function of the part that is to go into the aggregate, that decides the material. Then the process, how that component is to be manufactured, that decides the material, and also the shape. The shape, like if it's a fabricated or it can be cast, or the final shape, how it is to be used. Also the criteria for material selection. So the ultimate target while selecting material is to make a cost-effective choice meeting all functional, manufacturable and legislative requirements. So the ultimate goal still remains that the final selection should be cost-effective. And recently, due to many legislative requirements like fuel consumption or CO2 emission coming, so the target always now on it for a material to be used on an automobile is that it should be lighter. So the strength to weight ratio should be the best possible and it should be cost effective. And the material which is being used in automobile are here shown divided into the metals and like plastics on this sheet. In the metals, there are ferrous and non-ferrous materials, and the maximum the ferrous material, the vehicle, like if you see a tractor vehicle, then the maximum material we use is steel. You can say up in a tractor up to 80 to 90%. The weight wise, it's all steel being used. In a car, maybe this is around 70%, but tractor being a without any chassis component, the aggregates are itself chassis. So steel is maximum used, steel and cast iron. Then stainless steel in automobile are also used to maybe around 10%. Then while we are making the components of automobile, die and tools still will be used for different forming operations or in the dies we make, or it may be forging dies or casting dies. So die and tools still used, and cast iron for all the critical shaped components like gearboxes, crankcases, cylinder heads. So cast iron is at the top because to make the engine and copper, zinc, tungsten are also used. And then so this covers the metallic part, and in the plastics can be divided thermoplastic, thermosets. So this lists the acrylic, nylon, ABS, polyethylene, polycarbonate, PVC. So this PE and ABS, they are the maximum used in the vehicle, two materials. Phenolic, epoxy. Typically, the epoxy and polyester being used in fiber reinforced plastics as the resin part, and in the rubber elastomers, rubber and PU and silicon are used. Rubber, all the sealing joints or the O-rings, the seals, they are made of different compounds of rubber. Polyurethane maximum being used in the seat, and silicon for as a sealant being used widely in the automobile. And then the the third material being used is the ceramics. It may be carbide, nitride, graphite, diamond, glasses, glass ceramics, like in the headlights. So ceramics and glasses used. And the composites, because of the lightweight criteria, the use of composites is increasing. So they may be glass filled reinforced plastics or even type carbon fiber reinforced plastics are being used. All these we will discuss in detail when we do the topic. So in generic, the total materials there are the to hundreds. Commonly used materials I have listed in the next 3 slides, which we will discuss. And cast iron, the plain carbon steels with the 0.2% carbon. So they generally the mild steel, you can say the plates, even the sheets. So they are generally of this low carbon steel. Then medium carbon, plain carbon steel, again having 0.4% carbon. So these are hot rolled or cold drawn. So this type of steel is used for mild, you can say medium rooted components. And the first these two steel which we have seen, they are without any heat treatment. They are usually not heat treated. But for strength, when we need to heat treat, then we need to use material like 4140 EN19. So like EN19 is the induction hardening steel, very commonly used for heavily loaded components like crankshaft, acting rod, which can be like crankshaft can be induction hardened, and it has alloying elements chromium and molybdenum, which so that the after induction hardening the strength properties is kept that can be achieved. Then again, some further higher alloy materials 434, 4340. These are the SI designation on the, you can say, the left, and the EN are the European. The EN24 again heat treated alloy steel, nickel, chromium, moly also. Now in this category nickel comes. So nickel being an expensive material, only wherever it really requires we need to go for this material. Otherwise 4140 EN19 is used. So these are the top four are these steels. Now we have the stainless steels. The popular grades of stainless steel are 304, 316, and then comes the tool steels. O1 is the oil hardening tool steels. By tool steel, what I mean is the steel which are being used to make some dies or some, you can say, taps, drills, or such cutting tools also. Then the next class of material are the cast iron, FG260. The 260 denotes the tensile strength. So it's, you can say, most popular cast iron. And in the aluminium category, in the sheets or plates category, 2024 sheets, this O, T3, T4, T6 are the heat treatments we do for the aluminium component. This we will also discuss later. And then 3003 sheets are plates are there, 6061. So you can say in this order, the tensile properties are better. 7075 again, and then the copper grades are there. And in aluminium alloy for the components which are cast, the popular materials AC4B plus T6 denotes the heat treatment. So this is a like material being used for LPDC and GDC, and ADC12 is used for HPDC, high pressure die casting. And the most commonly used plastics, ABS, PC, polycarbonate, nylon, PP, polystyrene. The, of course, maybe another 10-15 types of plastics are there, but these are the most popular in an automobile. Ceramics, alumina, graphite, and then the composite materials, particularly the fiberglass. Fiberglass for the shaped components like bonnet. So such components, fiberglass is very popular. In the case of vehicles, you can say, which are made in low volume, but the production is not that much, so because it is very cost-effective solution. So fiberglass is used, and also carbon fiber reinforced plastic is becoming very popular, and then graphite and epoxy. So you can say in these 25 plus type of material, we cover maybe 90 to 95% of the materials which a automobile consists of. So now we can further see the details of these parts. Okay. This slide covers the low and medium carbon steels which are being used for structural purpose in a vehicle. Like if you are seen a tractor where most of the components are fabricated, like the front axle beam or the front axle, and then you see the bonnet. Even same is applicable to cars also. It may be the bonnet, the fenders. So all these components which are required to be of very cost-effective solution. So they are either low carbon or medium carbon steel, and the three types of steel depending upon the thickness of the sheet or the properties required. These are generally hot rolled. They can be they are taken from 3 IS standards. So the selection criteria you can see is the sheet thickness. So when we require thicker sections, like from 5 mm to 100 mm, then the available steel as per IS 2062, we have to refer this one. And this is for hot rolled, medium and high tensile structural steels. And the grades available from different wood suppliers like Tata Steel or SAIL, they are classified with designation E165, E250, which are shown here, right? So 165 or 250, it is showing the tensile. So for better material, we will load the E350, 410 material. And also the selection depends upon the type of welding we need to do. Suppose if welding we want to do more, then maybe we can go for quality E. So depending upon the welding and the strength, we can select from this type of steel. And the typical components which this is used is like the front axle bracket in a tractor, or even some structures supporting other frames, or supporting you can say the structures supporting the fenders. So we can use this IS 2062 steel for that. And the next type of steel is based on IS 5986, and the sections, if you see available, the sheet section is 2.5 to 5 mm. So wherever there is, you can say slight fabrication work, where some you need to shape the part. Of course, it's not a deep draw, but normal shape you need to do. Maybe a 90-degree bend is there. So there we use IS 5986 materials. We order based on this. The thickness, as I told you, 2.5 to 5 mm. And similarly, tensile of these are yield properties are shown of these are given, and the designation is also based upon this. So when we order, we can order as per IS 5986, like 3 to 5, grade designation 3 to 5. And the earlier, still these are the new designations. The earlier designations which still are popular in market, if you need to order, are the FE330, FE360, FE410. The old designation are continuing in this. And the type of components for this which we make are like the vehicle chassis or the cross members. So you can say all the load bearing fabricated components. Then we go for IS 5986. And then for sheet metal or the skin panel components, the IS 1079 hot rolled carbon steel strips we use. So they are classified as per the old designation, the ordinary quality O, D is the draw, then deep draw, EDD, and then the EDD stabilized. So O, D, DD, EDD are very popular grades which we need to order when the component is to be deep drawn, you can say. The example can be like a sump, the engine oil sump with the typical structure it has, or even the like a bonnet, because of the profiles we need to give. So those components we need to go for maybe EDD, extra DD, draw type EDD as per IS 1079. So the wall thickness is less in this for selecting. Now these three designations, they are, you can say, the graded structural steel components. When you go to market to an ordinary store, iron store, the material available there is all MS. So for an automobile application, for a tractor application, or off-highway vehicle application, then we need to order the graded steel, because the consistency of the properties and the tensile, and that will be better. So you can say, for the load bearing components, we need to order the graded steels. Otherwise, all these are available in the general market as a MS. That's also available. In this sheet, you can say the chemical composition is seen. Just I highlight the carbon in all these structural steel. You can say 0.15, 0.2. So carbon is usually less than 0.25. And for the strength part, manganese is the chemical which is giving the strength to these steels. So the chemical composition of manganese is increased to having a more strength, right? And apart from this IS3 which we discussed, some special steels are also available, like SAIL Steel Authority of India. Their grades, SAILMA grades are available. Wherever further, you can see the further better tensile or yield properties are required, then we order as per SAILMA steels. So there also the manganese goes up to 1.5% for the strength part. And this I have written this killed or semi-killed, where the phosphor and sulfur are reduced, or you can say controlled, by aluminium adding process. So that's the killed or semi-killed steels. Because the phosphor and sulfur, you can say, are just like a poison for the steel. So we try to limit their percentage, their like impurities for strength control. Again, just an explanation which I made you for this deep draw and extra deep draw sheets is given here. And also a few words written here on the SAILMA steels. So these are high strength micro alloyed steels having a combination of desirable properties not attainable in conventional mild steel. So they have higher yield strength, fatigue properties, and weldability and good formability. So their SAILMA steel or this high graded steel application, so they are used in ships, railway wagons and carriages, pressure vessels, pipes, heavy duty transport vehicles, earth moving equipment. You can say like the Hydra cranes you must have seen. So all the booms of that, because of being so heavily loaded, and generally if it's a 12 ton, people use up to 25 ton. So the SAILMA steel is very popularly used in this type of application. This we already covered. Okay. Now we seen in the last slides that the manganese we were changing for having better properties. So to define the overall impact in a steel, we see the carbon equivalent. So the carbon equivalent is calculated by the carbon as a whole, you can say, with the division by 1, and manganese by 6, and other alloy chromium only by 5, and then adding all these. So depending upon the total carbon equivalent we get, the tensile or the UTS or the yield are based upon that. So you can see like a E450D steel with a 0.46 carbon equivalent, which is better than E250. So the tensile properties is going up to 450 against 250. So this is how we can judge the tensile properties, whether carbon is more or the manganese is more. This table gives the, for the different steels which we discussed, the yield strength and the ultimate tensile strength, and the percentage elongation. By percentage elongation, you know, we mean the elongation what happens in the UTS when it ruptures. So that is the percentage elongation. So like for our DD and EDD, which I told you are the deep draw type of sheets, we require the percentage elongation to be more. Only then we'll be able to deep draw it in a die. So the elongation is higher. But in the higher tensile grades, which we use for other structural thick plates, the elongation is reduced. Similarly, the Selma steel properties are also given in this table. Again, the tensile properties for ODD sheets are again given here, along with the elongation allowable. And here if you see some now with the kind of requirement in cars for the components like bonnet, the bonnet in the front hood, or even the, you can say, the hood bonnet. So now steel which are further being used, these steel are dual phase or trip sheets are available. So by these, the properties of these is that, like, the original structure may be austenite in these sheets. When you cold work it, that austenite starts changing to martensite, which is a harder, more strength component. So this sheet originally has that it can be deep drawn. The hardness is low, but by cold working we are able to make it stronger, so that impact resistance or the toughness increases. So this dual phase or the trip sheets, recently they are being used for these components, so that easy to draw, and then they later on have strength also. And earlier we seen that some micro alloying elements are also added, and vanadium, titanium, they are also present, but in very low percentage. So in the different steel which we discussed, so this total of these can go up to 0.25, 0.2, so very small percentage of in the chemical composition they are present. So these micro alloying elements, as I told you, is for making these like dual phase or these trip sheets, where by the cold forming we are able to improve the properties. So up to now we have covered the different structural steel, where the outer panels or the chassis part or the structural support parts, the fenders or the outer skin panel or the structural members in a car or a tractor. These 3-4 steels cover all the grades. Now we can move to stainless steel. Though stainless steel in a aggregate like a tractor, not much of stainless steel is used, but in automobile like cars, the stainless steel is quite used in maybe around 100 to 150 kg in a car consists of stainless steel. So by definition, you all know the stainless steel where the chromium percentage is more than 10%. That's considered to be stainless steel. And stainless steel is divided into three major categories: austenitic, ferritic, and martensitic. Right? Austenitic have two major alloying elements: chromium 16 to 26%, and nickel is also there, 22%. But you know nickel is very expensive, so generally austenitic steel people avoid to use. But its the properties are like non-magnetic and excellent corrosion resistance. So you can say this is an expensive stainless steel, right? Weldability is also good. So and their designation starts with 3. So wherever 3 some digit is there, so it's a austenitic stainless steel. Then the second category is the ferritic stainless steel. There is no nickel in this, and the chromium percentage is little higher because there is no nickel, so it goes up to 30%. And they are identified by 400 series. And then the martensitic. Here the chromium is less than ferritic, but the carbon content is a bit higher. So due to this carbon content higher, this martensitic, by the name also it suggests, this can be heat treated. The other two stainless steel are hardly heat treated for getting further better strength property. But carbon being little more, so it has also tendency to corrosion also. The other two steel, the corrosion properties are much better. Typically the austenitic stainless steel. So the generally available steel AISI 400 series, and the carbon is not much, up to 0.08%, and their grade 410 is a very popular grade available. We use in the automobile, and even also for the general construction or even our household use. 410 is very popular, and this can be, depending on the chromium or carbon, they may be martensitic or ferritic. Now increasing chromium or reducing carbon results in a ferritic stainless steel, which is non-hardenable by heat treatment. From 410 we can go to 430. So, and chromium, in this the chromium is higher, therefore 430 stainless steel 18% chromium is more corrosion resistant than type 410 stainless, where that only 12% chromium is there. So wherever the issue is that due to maybe temperature is there, corrosion is happening, or the environment condition are there, then we can go for 430 stainless steel. Of course, as the chromium is increasing, the price is also. And the better stainless steel, as I told you, are with the 3 series because nickel is there. And 304 you can say is the number 1 stainless steel, whatever we generally see in an automobile or even in buildings or metro trains, metro train stations. It's 304 stainless steel they are using. So popular are 304 and 316. And another, while selecting the stainless steel sheet or other material, we need to specify the finish also. What kind of finish is there on the sheet? So the finish grades are like number 1, CR, 2D, 2B, number 3, number 4. So it depends upon the manufacturing process, whether the sheet is annealed, pickled, or re-rolled, or some you can say with the external grit, we have done the polishing. So depending upon the operation we have done and the kind of finish we want, so we specify the finish also when we order the stainless steel sheets. So like for or decorative purposes, we can order number 8 finish stainless steel sheet along with the designation like 304 finish number 8, right? But generally available in market are like number 1, 2D, 2B. They are popular. The sheets which we use for this general purpose, they are of 2D, 2B quality. As I was explaining, 2D finish cold rolled, annealed, and descaled pickled, and 2B finish is cold rolled, annealed, descaled, pickled, and then skin passed. Again, you can say cold rolling process done for finishing and sizing. And for mechanically polished, number 3 finish, so ground with the 100 to 120 grit size of resin. Similar other finishes are there. This table you can refer for the chemical composition for different stainless steel available. Again, this table you can refer for selecting, comparing with the international rates. So this table can help in that. Yeah. Here just a note given regarding this nickel. As I told you, that nickel being very expensive. So generally the 3 series are to be are avoided. Stainless steel starting with 3. So the secret of ferritic stainless steel is high chromium, perhaps moly, and little or no nickel. In this page, the popular grades are mentioned like AISI 304. The world over, this is the most popular grade, and it is also called 18/18, meaning 18% chromium and 8% nickel. So it has organic corrosion, can be used in food processing industry and this most chemicals. And the second most popular grade is 316, and popularly called A4 stainless steel, and used and called marine grade stainless steel, used primarily for its increased resistance to corrosion. So for better corrosion resistance, in place of 304, we can go for 316, and is used in cutlery, high quality cookware. And then comes the AISI 409 grade, ferritic. Here no nickel, only chromium. So for high temperature applications, 409 can be used, and it is the least expensive stainless steel available. 430, the most widely used plain chromium only stainless steel of a general purpose. The corrosion is better. Corrosion has high level of carbon that allows it to be heat treated. So the main advantage of a 430, 410, they are heat treatable. So components which are later to be put into fatigue or bending stresses, so which requires to be heat treated, we can use this. And typical applications can be, you can say, the valves. The engine valves, they are also made of stainless steel to wide provision. So this 430 is a popular grade for this. Here some applications of this stainless steel are shown, like the shelters or even the total metro train. It's all stainless steel 304 used. Even the Petrona towers are grade 304, 316. Burj Khalifa to avoid rusting and for a long lasting life. So stainless steel is the material even for structure. So this table just for comparison of the corrosion resistance, ductility, formability, so this can be referred. So 316, 304, if you see, the ductility is very, very good. So, in the buildings or in the construction activity, 304 and 316 are the most popular grades. And if we see the cost wise, all 316, 304 they are having nickel, and the corrosion properties are very good. They are just like fit and forget, so the life can be maybe 30-40 years without any problem. And low nickel steels like 430 or the lower grades, they are cost effective, but they are susceptible to corrosion. The corrosion is poor in this. So the selection criteria for stainless steel is the corrosion properties that the component is demanding. It may be due to the temperatures, or you can see the application, like if it's a C application, so then better to go for a nickel chromium steel. And then the other criteria is the cost, and also what's the life of the component where it is going to be used. That we can make a choice from that also. This table is for your reference for converting the standard wire gauge is available to the side. This is handy for you. So this graph gives the consumption of the various steels available, like chromium nickel, meaning the 3 nickel is there, so the starting with 3 grade, so the around 70% of all the applications, so chromium nickel stainless steel is being used. Then chromium manganese around 9 to 10%, and chromium alone, starting with, you can see the 404 or 416, so around 25% of all the stainless steel is with chromium. Similar figures are there. 300 cc, 300 series, around 63% world over steel being used, chromium nickel, and then the 400 series 24.8%, 25%. Then there are available some duplex grades also, where ferritic and austenitic grades, it's on the borderline. The steel available, stainless steel available is on the borderline. So those grades are starting with 2205. And in case of stainless steel, there is a PR and PREN number, which is to evaluate the corrosion resistance of the steel, which we need to specify. PREN number. Here, just what I was saying, the stainless steel depending on the chromium equivalent, like we see in the carbon equivalent in case of steel. In case of stainless steel, chromium equivalent, which is equal to the chromium percentage plus moly plus 1.5 times silicon and other micro alloying elements. This gives the chromium equivalent. So the three stainless steel which we have seen, the austenite, martensite, and the ferrite. Then in between some duplex grades are there, so which fall, you can say, in austenite as well as ferrite, or some here which fall into austenite and martensite. So A plus M, austenite and martensite, right? So some duplex stainless steel grades are also available. Okay, this full pitting corrosion, as I was mentioning, this PREN number is there, which is percentage chromium plus 3.3 into percent moly plus 16 into nitrogen, right? So this number derived, if for different steels, if they are having same PREN number, then the corrosion properties are same. So the 33 pran number steel is there. It may be austenitic or ferritic. If the pran number is same, its corrosion resistance property is the same. So we need to specify this along with while ordering the steel also. So this is pitting resistance equivalent number. Pran is pitting resistance equivalent number. So the average passenger car uses about 15 to 20 kilos of stainless steel, mainly found in the exhaust system. Because the exhaust system, the temperatures are higher. So normal steel can corrode due to high temperature, at high temperature oxidation and in the moisture environment. So it can corrode. So to extend the life as well as to give the better aesthetic, the exhaust system is generally made of stainless steel. And the popular stainless steels used are 309 and 310, where the chromium is up to 25% and nickel 20%. 340 again, 304 is again the popular one. And if you see in the total exhaust, starting from engine is this side, and this is, you can say, the hot side where it is coupled with the engine, and the lower parts where the muffler or the tailpipe are there, they are the cold side, right? So depending upon the hot side or cold side, the stainless steel selection is done. Another typical application of this is happening in the, this is shown a oxycat brick for production is like a after treatment tool in a diesel engine for oxidation of hydrocarbon and carbon monoxide. So earlier it used to be of ceramic, and coated with the noble metals. Now, due to some industry, like you can say in a three-wheeler application, where the vibration and the vehicle has to go in a rural and rough and tough type of condition, they have shifted to stainless steel brick. So the whole total construction is of stainless steel and then coated with noble metals and precious metals. So exhaust system where the maximum stainless steel is used in a car. Similar here in a bike also, the exhaust system shown, the maximum stainless steel. 409 grade we are using. Again, if you see the cylinder head gasket, because the temperatures and the strength requirement are such, and the creep properties also define that now we use multi-layer stainless steel gaskets. Earlier it used to be asbestos and one or two layers of gasket. Now asbestos not being environment friendly and being banned, so shift has happened to stainless steel sheet only. If you see in this right side, so some 4 or 5 stainless steel sheets, they are joined together with rubberized compounds from the sealing point of view. So stainless steel in exhaust gas application. Even this is for the cylinder head. Even all the joints in the exhaust system, they also use stainless steel gaskets. Now with the in diesel engine, with the coming of further tighter emission norms, right from BS3 bar stage 3, bar stage 6, 4 and 5. From BS3, the EGR is essentially required for NOx reduction. So for again, the exhaust from the exhaust side has to go into intake. So the temperatures are going to be minimum 200 and going up to 600 degrees centigrade. So if we use a normal even seamless pipe, so that can also corrode. So only stainless steel pipe and even this flexible joint with the stainless steel braiding is being used for EGR system. Again, this sheet is giving the chemical composition of austenitic, ferritic, martensitic, or duplex precipitation hardening stainless steel. Austenitic, the tensile properties, they are going up to even 325, and ferritic is less. Martensitic, because it can be heat treated, going up to 285. So this gives you just a different chemical composition and tensile properties. Right. So till now we have covered uh, normal structure steels, the 3 or 4 grades which we discussed. Then we covered the stainless steel. In stainless steel we covered another the 3 grades which we divided into. Right. So mostly the material which we have discussed till now, it either goes into outside of a vehicle or in the exhaust system like this stainless steel. Now we can see the material which goes in to make the vehicle, you can say the powertrain. So what goes into gear and shafts or the engine components, and what kind of heat treatment is required to be done. So, and why we set that material, we can now see in the further topics. The, typically in the gearbox of a car or gearbox of a tractor, the gears itself, the weight of the gears or the forgings which we use, they may be around 25% of the total vehicle weight. So that's the importance of powertrain materials which we use, and the similarly rate depending upon the chemical composition and properties required. So the rate may also vary from rupees 50 to maybe 85, rupees 85. So same material can be used at the rate of rupees 50 per kg, and similar available at 85 also. So when we can use 50 material and 185, that choice we have to make. So first we see the case hardening steels. So you already know by case hardening, we know that if suppose this bar is shown here, only the outer layer is hardened, right? So case is hardened, the core remains soft, right? So the hardness of core is not as much as the outer case. So this type of steel is the case hardening steel. And the case hardening, the most popular process for case hardening is by carburizing. So in carburizing, the temperature which we heat it to, so that we take it to austenitic range. So where we can add carbon into the low carbon steel. So generally the carburizing steel is low carbon steel, maybe 0.2 up to 0.2% or less than that. So we have to build carbon into that. So we slowly heat the material, and around 900, 950, we let the carbon absorb into the case, right? So the time like is shown maybe 6-7 hours, the carbon getting built into. So this time period will depend upon how much case depth we want, right? So if we require say 1.5 mm case depth, maybe we need to keep it at that temperature for 8 hours. But generally the specification given up is 0.8 to 1 mm, so we can keep for less time. So in this way the carbon buildup happens, right? Then we after the required carbon buildup, maybe up to you can say 0.6 or 0.7, because more carbon that will not going to help us. So we need to increase the carbon in the outer skin only, 0.6% you can say. Then we again bring it temperature by 100 degrees, then keep it at that temperature so that homogenization happens. And then we do the quenching. So quenching preferably done in oil, because water quenching is very severe, so that can result into cracks, micro cracks, which while we grind, then they appear on the surface. Okay. So we do sudden quenching, right? And now this whole process of heating and cooling. So internally, you can say this quenching stresses will be always there in the component. To remove those stresses and to stabilize the structure, then we again heat it to tempering temperature up to 200 degrees centigrade. Let it the heat go up to the inner core, and then we slowly cool. So this carburizing, quenching, and tempering. This is the whole case hardening, carburizing process for having increasing the hardness. So what happens when we quenching? The structure changes to martensite. Martensite, you know, is the harder structure. The carbides are formed with the different alloying elements are there. So now since the carbon has picked up only in the outer structure, so the hardness increase will be happening there only. The inner core, the carbon was not that increased, so the core will remain soft. So the component will be having a outer hardened case and the soft core. So for all the wear application or the contact stresses, the outer harder case can take the loading and will not wear, and the life will be more. But for situation where impact is there, so the inner soft core can show the ductility or the toughness it retains, so that the part does not fail in bending. So by this process, we have taken bending failure also, which may be happening due to impact, and also wear or contact stresses related failure due to, as we have hardened these. So we continue after 20 minutes or what time?
Okay, dear participant, the tea break is there for a period of 20 minutes, and we'll reassemble at 11:30 sharp. Okay.
समझ भी आ रहा है वैसे तो इतने सामने थोड़ा मैं थोड़ा कंपाइल किया
उनका वो कैसे ऑन करो हाँ बंद क्या है
अपना तो हमने कभी इनका भी ये ऑन करेंगे ना। हेलो अरे जोशी जी कौन कर रहा है तो यार
करो करो इसको करो
माइक बंद कर ले स्पीकर तो चलाओ
अरे इसको वो करो पहले एक बार इसको ऑन करो हाँ
इसको ये लो
अब वहाँ से वो करो वहाँ से हाँ
एक भी देखते आ रहा है अभी के बाद कॉल करो इसकी आवाज आ रही है।
हाँ जी सर आ गई ना बोल तो दिया
हेलो
हेलो हाँ जी सर
हाँ आवाज आ रही है।
हाँ जी सर आ रही है
दूसरा फोन में कभी क्या
टिकट वाले
टिकट वाला शुरू हुई
ये आशीर्वाद आ रही है सर वाइट वाले से लेफ्ट वाले से आ रही है ओपन करना है इसको अनम्यूट कर दो
पढ़ो ना इसको, यही तो बात है, पढ़ो इसको, सब कुछ दे दिया मैंने, सब कुछ नोट में बताया, फर्स्ट में सब करवाया, 2 बार करवाया, 1 बार नहीं।
Yes. Okay. So we start again. And the last point, what we were covering was the tempering after the carburizing and quenching operation. So, importance of tempering for having a tough core is very essential. So, we should try to do the tempering, and sometimes, if not done properly, it can be very catastrophic. But typically, in case of gears, a tooth uprooting can happen. So here the process is defined. The component is heated to 850 to 950 degrees centigrade for carbon buildup, while the phase is austenitic. And when the carbon percentage up to 0.7 is increased, then we hold it for some time and then do the quenching. So an important microstructure goal during carburation is a stable, uniformly fine grade austenite. A uniform austenite grain size results in low distortion after heat treatment, while a fine austenite grain improves fatigue resistance and toughness. So the whole process results into a harder case for bearing the load, and a tough core in case of impact loading cases. And the stabilization is achieved through grain refinement. So if you see any gear or any component drawing of a carburized component, so the grain size and the type of grain structure, they are also specified. So after doing all the heat treatment, so we take the microstructure after seeing that the hardness is okay, and we see the micro hardness for the A step, and then also see the structure to see the grain size, what type of grain structure is it. So if you see in case of a geared component, here if you see this white, this is the martensitic hard layer, and in between structure is sorbite, and in the core it's the original structure, which is the software. So in case of a gear, if you see, the hardness desired is even in the root area, because this compressive stresses build up due to carburizing and quenching. They will also help in bending and the failure of the thread at the root level. And in case of gears, the case depth is given from 0.8 to 1.2 mm. We will see how we define the case depth. This we have already covered. And here are examples of critical loaded components which are usually case hardened for achieving the hardness and tough core. So like this is the gudgeon pins of an engine. This is crown wheel tail pinion of a tractor or a vehicle. Similarly, here shown is a camshaft where the intake exhaust lobes are hardened. And also here is shown a cluster shaft of a three-wheeler application. It's a 1, 2, 3, 4 gear component, and this is the primary production from the engine. Similarly, the sleeves used in for holding tools in a machine are there also case hardened. And the steel selection, or how we select a case hardening steel, as I told you, the price may vary from a 50 to rupees 85 or 90. So what is optimum for typical application? So if we see, this is the 8 or 10 grades of steel which are popular for case hardening, starting from C10, which is almost mild steel, 0.1% carbon. Then the C20 is there. So these are basic carbon, low carbon steel only. And then the alloy steel, 16 mm CFI, the 20 mm CFI. These are manganese chrome steels. Then SE 8620. In 8620 you will find some nickel is there, and moly also coming. Then similarly 15 chromium nickel 6 here nickel is there, the EN353, and this is the highly alloyed for very tough gear applications. And out of all these, the two most popular gear and shaft material which are case hardened are 20 mm CFI, which is only manganese chrome is there. So carbon of course 0.2, manganese 1.25, and chromium is 1.15. So this in average loading gearbox shafts of gear, 20 mm CFI is a very popular and cost-effective solution. So this is available at a rate of maybe 60 rupees per kg. And if we have further highly loaded gear shafts, then it is recommended to go for 8620 because it has moly also and nickel also. So molybdenum is added for increasing hardenability, and nickel is for increasing the toughness of the core. So this is the difference between 20 mm CFI and 8620. Similarly, another popular material is EN353. So 8620 and 353 chemically composition wise, nickel and moly are there in both, but content is more in EN353. So if we have gear or tooth failure happening even in 8620 or pitting failure happening, then we can go even for EN353. So in case of if we see in the earlier slide, like in a normal gear which is coming in gearbox, the loadings are, it's the primary reduction. So the torque here in the primary gear stage is not that high. So we can use 20 mm CFI. But ground wheel tail pinion, since it's being used in the final reduction, here the torque levels are higher. So we will go for 353, which is a better material from the fitting point of view, from the core hardness point of view. So EN353 is generally recommended. And advantages of these alloying elements we will see. Hardenability, of course, is we know. Hardenability describes how deep the steel may be hardened upon quenching from high temperature. So the depth of hardness depends upon hardenability of the steel. And generally for each and every steel available commercially in market, the hardenability is defined by its Jomini value, where the piece after carbon buildup is cooled from top, right? And the hardness of the piece is studied along its length. After cutting, sectioning, and doing a micro hardness level test, you see hardness from different distance. And here in this graph is shown like distance from point spread, 0, 10, 20, like that. So if we see the lowest most curve, 17 CF3, right? There is no manganese, there is no moly or nickel in this. It's a low alloy steel, you can say. The depth for the same, like for hardness of 30, the depth is going only up to 7-8 mm, right? But in case of a highly alloyed steel, under the similar conditions of quenching, the depth is going up to, you can say, 30 to 40. 30 to 40 mm. So if we want more case depth, meaning if we want the hardened layer, the martensitic layer to go deeper deeper into towards the core, then we need to go for high alloy steel containing nickel and molybdenum, right? So when we select, as I told you, the Gemini values, depending upon the application, we select the steel depending on the Gemini value. Now, in brief, this is very interesting information on the effect of alloying elements, because hardness of a component depends on the carbon percentage, right? The alloying elements role in hardness is very less. So we can achieve the desired hardness by increasing carbon also, right? But it has its consequences. Simply raising the carbon content would raise the hardenability, but this approach sacrifices toughness. The core toughness of the core will also become poor. That will also become high, and it will feel like a brittle fracture. So whenever we need a tough core and harder case, then we need to have the add the alloying element. This is the low carbon steel, plain carbon steel, you can say. Then in case of manganese chrome steels like 20 mm CR5, these are these type of case hardening steel are not applicable when long fatigue life and high toughness are required. So in the medium range. So you can say in a gear in the primary stage only, where the torque increase has not happened to that extent, we can use 20 mm CR5 or 16 mm CR5. But as we move towards the rear of the gearbox in the final reduction stages, then we have to go for steel containing moly or nickel. So moly is used in carburizing steels to increase the hardenability of the low carbon core and toughen the high carbon case at the same time. High performance nickel chrome moly case carbon steel, which you can say the ultimate in case of case hardened steel, provide deep hardenability and possess high fatigue strength. Currently, this 18 chromium nickel moly 7 is the standard gear steel for windmill gearboxes. You can say the most heavily loaded gearboxes. For large and heavily loaded gears, the following priorities can be defined: increased core tensile strength and toughness, high fatigue strength in both core and case, improved hardenability, low distortion upon quenching, improved properties at elevated temperature. So these are the requirements of a case hardened steel, right? And for achieving these are simple approach: prevent intergranular oxidation. So this is done by reducing silicon, manganese, and chromium. So you can say that aluminium kiln or refined steel we should use, where the phosphorus, sulfur, or silicon they are not there, or to the minimum possible percentage. Improve hardenability. So addition of moly helps in that. For toughness, again nickel is the main alloying element. Fine and homogeneous grain size. So some micro alloying elements, niobium, titanium, and they are added. Strengthen grain boundaries, reduce phosphorus and sulfur. And just a definition of case depth. What's case depth? So at the surface, the hardness, like in a case hardened steel or gear or shaft, is around 58 to 63 HRC on the Rockwell scale. That's on the surface. But as you move 0.1, 0.2, 0.3, up to the case depth, what we specify. So we need a 550 HV hardness. So wherever 550 HV is achieved, that's the case depth. So it may be 0.8 mm, 1 mm, or 1.2 mm. So hardness will reduce, and generally this 550 HV is the criteria, or the other criteria is that hardness where the case depth is defined will be 80% of the surface hardness. So if on the surface 60 HRC we are targeting, so case depth is defined where 80% of 60, that's 48. So 48 HRC, that depth is the case depth. So either 550 HB or 80%. So this again shows the similar table which we have earlier seen. The case depth is given here. Case depth of various case hardening steel with same carbon profile. So the carbon percentage you can is same around 0.2%, but alloying elements are different in different steels. So if we see like a 16 mm CR5, the case depth is 1.42 mm because manganese and chrome is there. So case depth achieved is 1.42 mm, and in case of a simple 17 CR3, it's only 0.8 mm. So to have a more case depth, we need to add the alloying elements, which we have discussed earlier. So now we have seen the case hardening by carburizing. So the second type of steel or the components where we require the outer surface to be hardened, then we use the induction hardening steel, right? So depending upon the component or on the steel, we decide which is to be induction hardened or case hardened. So case hardened carburized steels we have seen where the carbon is in the range of 0.2%, and then we add alloying elements for case depth or for the core hardness. Now we see the induction hardening steel. Induction hardening process, you have seen that heating of the surface is happening by the eddy currents generated by a medium frequency or a high frequency machine. And other differences of this vis-a-vis case carburizing is that it's a very fast operation. The whole operation can be completed in 2-3 minutes, while we process in the case carburizing you see maybe 8 to 10 hours, then tempering. So the whole process is very cumbersome and long, right? But advantage is also there. The controls in case carburizing are much better, and wherever we need to do the hardening of the whole component, like in a gear or a shaft, then we go for case carburizing with carburizing, and if only the selective portions are to be hardened, then we go for induction hardening. So in a way, this is a faster and cost-effective process. So induction hardening, this is to be done on carbon steels having carbon in the range 0.4 to 0.45%. So carbon is already required to be there because we are not adding. In case of carbon, we have first added carbon, then done the quenching. Here carbon is already there. So advantages, as we already shared, it's a fast process. No holding time is required, hence more production rate. No scaling or decarburizing. More case depth because carbon even in the lower depths is already there available 0.4 to 0.45. In case of carburizing, we enrich only the outer core only, outer case only. Sorry. Here carbon is already there, so if we heat up to the required austenitic temperatures, so the case depth up to 8 mm can also be achieved. While in case of carburizing, up to 1.5 mm is the maximum. And selective area hardening is possible. Wherever we want to increase the hardness, we will heat only that area and quench that area. So less harmful to the environment because process is shorter. It's electric driven only. In case of carburizing, some salt baths are there for some processes. So that's a chemically controlled process also. And since only the local component is heated, the distortions are also limited. In case of case carburizing, the whole component is to be heated, so quenched. So the distortion is always there. And in subsequent processes of case carburizing, we have to straighten the shaft before grinding, putting it to grinding. Here, such a distortion is not happening. and the common induction hardening steels, EN8, ENAD, they are popular. EN9 is also very popular. EN18, like EN8, ENAD, EN9, they are carbon steels only, medium carbon steels. EN18, EN18D, EN1924, these are all alloy steels containing chromium and molybdenum. Right? And if we see the application of medium carbon steels, so these are standard stress structural components, and EN9 is used in some of the crankshaft, not all the crankshaft, where the loading pattern is not that severe. So crankshafts, and then EN18 and EN19, they are very popular in axles crankshafts. So mostly these induction hardening steel axles and crankshafts in an automobile, they are with the alloy, medium carbon steel alloy steels. And the alloying elements are chromium and molybdenum here. Chromium in the around 1%. Like in case of an axle, the case depth we require some 6 to 8 mm. The case we need to be very strong, 6 to 8 mm depth, up to 6 to 8 mm depth. Like here, different types of axles, like a tractor axle. Even these are tractor axles. So axle shafts are shown, which are usually induction hardened. So induction hardening is done. There are supplines in this area which will engage with the gear. So the supplying end is an induction hardened, and also the areas where bearings will be sitting, so those areas are induction hardened. These are the drive axle shafts of a three-wheeler. They are also induction hardened. This is a typical multi-cylinder engine crankshaft shown. So in crankshaft, because we do not require to harden the whole component, we need to harden only the journal area and the crank pin area. So we go for induction hardening operation in this, so that we can do the selective induction hardening. Similarly, here is shown a stub axle of a tractor. So all these gray areas, they are the areas which are induction hardened. This slide gives the our Indian induction hardening steel as per IS 3930. So medium carbon steel as well as alloy steels are given here. So we covered now the induction hardening steel also, which you can say constitute the gearbox, the powertrain part, the engine. So the total powertrain components we have done. Now we can see there is another designation of steel, which is the free cutting steel, right? So the steel which we discussed till now, they are used in components which are to be structurally loaded, where we need fatigue or pitting resistance or bending resistance. But in some of the components which form a part of a main component, like we do not require these strength properties. So only we want the metallic element only, right? So there we need steels which we can cut freely, so that the feed rate or the cutting speeds we have higher, so that the productivity is more, right? They are not heat treated. They can be zinc plated or yellow passivation, electrode deposition can be done, but no heat treatment is required in such case. So there we specify free cutting speed, where the production rate may be some 10,000 per day. So they are made on high speed, high productivity machines. So there are 4 main types of free machining steel, where lead is added, or sulfur is added, or phosphorus is added, and there are some super free machining steels with some microalloying elements, tellurium, selenium, and bismuth. Right. So what does sulfur does in these is, sulfur forms the compound manganese sulfide, which is soft and acts as a chip breaking discontinuity. It also acts as a dry lubricant to prevent a built-up edge on the cutting tool. So lead works in a similar way to sulfur. So the intent is that that to avoid the long curling chips of the cutting material. So we want only small pieces, they break down, so that we can give more feed and depth of cut. Otherwise, those chips, they will entangle with the tool or the workpiece, and we cannot run machine at a high productivity rate. And the popular commercially available free cutting steels are EN1A with lead, and again this material. So this is with sulfur, lead again. But now lead being polluting, so lead free cutting steels are available. EN1A, this manganese. Right? So if you see, in this table gives an idea of the tool life. This is normal EN1A, it's just like MS. And here we have added 0.09% lead, then 0.2% lead, and we can give cutting speeds much higher than the steel without lead. Right? And generally their carbon is low, and other elements we try to maintain. And the example of some of these are like the components which we make from free cutting steel. Like these are the adapters which are used in, you can say, hoses, the end connections. So just parts which are used as a passage for holding the pipes, clamps. So those kind of components are made from such, which can be electroplated, but no heat treatment of it. Another example is this simple like a key. So this is made from a free cutting steel. Now we move on to the ball bearing steel. So ball bearing steel, this is a true hardening steel, where the hardness obtained is same on the surface as well as inside. The in a ball bearing, the outer shell, inner shell, or even the ball itself, they are made from this high carbon steel, where the carbon is of the level 0.9 to 1.2 or 1%, and chromium 1 to 1.6%. Some of the even some dyes are made with these steels. Some low cost dyes are also made from these steels. But only precaution to be taken in case of through hardening steel components is that after hardening, tempering is a must in this case. Otherwise, it can even break if you fall from this side. It becomes so brittle. So without tempering, no through hardening steel can work. So these are the components shown here of a bearing: the outer ring, inner ring, walls, retainer. They are all made of through hardening steels. 100 CR6, which I shown you. Yeah, 100 CR6. This is very common material for bearing through hardened steel bearings. As you know, all these bearings are of two types. One is through hardening, and other is case carbon or case hardening, which we have seen earlier. Right? In case of through hardening, 100 CRS6 is very typical for through hardening steel material. Okay, now we move to tool steels, you can say. So in tool steels, hot dies, steel H13 or different grade of hot die steel, they start with H, right? They are to be used wherever the process, the metal is heated, like in case of a forging, or in case of a alloy which is cast, like aluminum casting with a permanent mold. So in such cases, the die is made of hot dies, and there are different grades of hot die steel: H11, H12, H13. But H13 is very popular in out of these, right? H3 chromium hot work steel, which contains strengthening agents such as vanadium and molybdenum. These steels are resistant to softening at elevated temperature due to the presence of chromium content and retain toughness with proper tempering temperatures. So the examples are typically applied in forged dies, die casting dies, volt dies, hot piercing punches, forming punches, and aluminum extrusion dies. So wherever the metal is heated while work, so hot etch is used for making the dies. And after the die has been made, we need to do the heat treatment, right? So hardening and tempering, because life will only come by that. Otherwise, the number of pieces taken out from a forging will not be that much. We need to have the toughness also. So we need to harden and temper also. And hardening, first we need to harden. So that it is heated to 850 degrees centigrade. Then taken to around 1000 degrees centigrade and hold there for some time so that the temperature is uniform throughout, and are then air quenched. So benefit of air quenching is distortion will be very low. So we can cut the profile of the component we want to make, and by this it's a simple quenching only, so the distortion will not be severe. And then to toughen, because in case of a forging, drop forging, the impact is huge. So we need to temper it. So tempering is done at a lower temperature, maybe 5 to 600 degrees centigrade, and then air cooling to obtain Rockwell C hardener 53 to 38. Right. So we have to restrict the tempering temperature in this range, because if we take it higher, then the hardness will drop. So more is the tempering temperature, then the ultimate hardness can drop. These are some of the H13 or hotter dies, steel dies shown here. This is a connecting rod, crankshaft, so such dies. So the H grade die steels are for hot working during process, and then we can see the cold work group die steels. Now the cold work components, they are like when we are doing a press job. We are doing drawing, blanking, piercing. So they are done on a sheet. So that the component is not heated. Then we use the cold work group die steels, right? And cold work tool steels, they can be the hardening, depending on the hardening we want to do. They can be oil hardened. The grades will be O1, O2, like those. If they are air hardening, then A1, A2, A3, like this. And then high carbon chromium grade D1, D2, D3 also, right? So they are divided into three groups. So oil hardening, cold group steels, the available steels are O1, O2, O6 grades. So the applications of O1 are like blanking dies, bushings, forming dies, master tools, forming rolls, gauges, trim dies. So all which are done at normal temperature. And they are cost effective as compared to the other cold working grades. So O1 steels are mainly used for short-run tools for cold forming dies, blanking dies, and cutting to trade and ambient temperature. So where we do not want the number of components to be taken from die, we can go for O1 grade in cold working steels, right? When the number of components are more. Okay, before that, this is the carbon analysis or the chemical composition of O1. Carbon is around 1%, and tungsten, chromium, vanadium, nickel. So all these are there to give it more life. And then the hardening temperatures are given. Tempering temperatures are given. Here you will see that the tempering temperatures are lower in this case. So wear for O1, the wear distance is average, toughness is average. So this is a, you can say, cost effective, low cost tool steel, where the volume of the components required is less, than we go for O1. Now A2 is the air hardening. So A2 cold work tool steel, right, is an air hardening cold work tool steel, around 5% chromium steel, which provide high hardness after heat treatment with good dimensional stability. It is heat treatable and will offer a hardness in range 57 to 62 HRs. So toughness is good, and A2 steel, it replaces the oil hardening O1 type when safer hardening, less distortion, and increased wear resistance are required. So it's little expensive than O1 because the properties we get and the tool life we get is more than O1. So, and the application almost similar if the number of pieces required to be more, blanking, punching, trim, forming dies, gauges, shear rates. So here you can see that some of the alloying elements are more, chromium is more, moly is more. And hardening is take slowly to 600 to 700 degrees centigrade, do soaking, then take it to the final hardening temperature 950 to 980 and allow it to compound to replace quenching air. So quenching can be done in air. Tempering is done at a lower temperature, tempered to 200 degrees centigrade for a balance of hardness strength or three. So as I explained you, the tempering temperature defines the final hardness of the component what we will achieve. Like in this table, it's shown if the tempering temperature varies from 150 to 400 degrees centigrade, the HRC hardness is reducing. So we have to finally balance the tempering temperature, because in any case the toughness is to come by tempering. Then is the cold work tool steel HC, HCR, D2. This is the, you can say, in the cold work tool steel, the best steel is the D2 steel, very popular, where the volume is huge. Then we go for D2, which is expensive. So carbon is 1.5 to 2.35, and chromium goes up to 12%. So it's almost becoming stainless steel. D steel, except D3 steel, all the other group D steel into 1% moly and air hardened. D3 steel can be oil quenched. And type D2 steel is the most commonly used steel among the group D steels, very popular. So it is easily machinable in the anneal condition and with heat treatment to a hardness in the range 55 to 62 HRC required for life. D2 steel shows little distortion on correct hardening. D2 steel high chromium content gives its mild corrosion resistant property in the hardened condition. So the dies will not corrode over the time, we can say. The life of the die will be low. Here given the chemical composition of D2 steel, you see the chromium is very high. And here given the hardening cycle for D2. So after soaking at 750 to 800 degrees centigrade, then it is taken to 1040, then stabilized at that time, at that temperature, and then quench accordingly. And for tempering again, tempered at 204 degrees centigrade, achieving Rockwell hardness 61. And if we increase the tempering temperature to 537, the Rockwell hardness drops. Right? And application of D2 steel is blanking dies, punches, piercing, forming, and DD dies, thread rolling dies, broaches, circular saws, sheet shear blades. So D2 is very popular in broaches also. Okay. So now up till now in the two die steel we have seen the hot working die steel and the cold working die steel. Now for typical applications of plastic molding, the popular die steel available is P20. So this P20, and the advantage of another of this is that this may be nitrided also. No hardening hardly requires in this type of application. So it can be nitrided without doing other heat treatments. So P20 is a chrome moly tool steel made specifically to fill the requirements for the machined cavities and forces used in zinc die casting and plastic molding. It is delivered fully quenched and tempered to approximately Brinell 300. Other hardness levels may be obtained through additional heat treatment. P20 composition and structure to provide excellent machining and polishing characteristics. So usually this P20 will be available in 300 hardness. So it will be difficult to do any other machining operation. So usually EDM, by EDM the profile is made, right? Then the die is nitrided so that we can see the desired line. Because in case of die casting, it may be aluminum or plastic injection molding, the pressures are there, the impact is not there. The plunger which pressure creates a pressure for injection molding or aluminum die casting, it moves slowly. If the pressures are there, there is no impact. So non-heat treated, only nitrided die can be used in P20. So similarly, temperatures for hardening temperatures and tempering temperatures are given. So another these, like we earlier seen hot die steel H1 series components. So this H1 will be used in case of like aluminum casting permanent molds or making some small portions of a die, right? But usually the when the large components are there, like in case of a crankshaft, where the whole cavity is in the block and it's bigger. So to make that die blocks are available. So it's a total large blocks are available. The die is engraved by EDM or by milling into it, then heat treatment, then it is used. The material may be same as H grade, which we discussed earlier, almost same to H grade. Right? Otherwise, the H grade we discussed earlier, like if the total die is maybe MS, only the portion which is to be come into contact of steel while forming, that is made of H grade. But in case of bigger components, that is not economical. So the die block itself is of the that material, right? So, and it is engraved, the impression of it engraved into the die block itself. And the popular die block grades are DB2 and DB6. Here also carbon is 0.5 to 0.6, and the nickel, chromium, moly, vanadium, all are there. The rate of any die block steel is around 170, 180 rupees per kg. It's an expensive material. So DB6 steel properties: tough die steel with high tempering resistance and good through hardening properties. This grade is usually supplied in annealed condition or cleansed and tempered to a hardness 370 to 410 or less. Application: standard steel for forging dies of all types: press dies, extrusion dies, retainer plates, armor trim dies, hot shear blade, and tool coaters. So the temperatures for annealing 650 to 700, and then cool in furnace, and for hardening 830 to 870, quenching oil or air, and hardness after quenching 58 to 56. Again, tempering we have to do. So again, the tempering temperature defines the ultimate hardness you achieve on the die. Now we will start with the next topic of spring steels. Now for spring steel, you can say it requires to be high fatigue component type of material. It is used like in leaf springs of automobile or other spring in a clutch, in a brake mechanism, in engine valves are used, governor springs are used. So different applications of spring steel in automobile are there. So and the material selection usually is done based upon the type of fatigue loading is there. It's moderate or heavy fatigue, you can say the number of cycles per second, which defines the fatigue. The more is the number of cycles per second, the better material we have to do. So classes of material available depending upon the fatigue required, fatigue properties required. So as per IS, these three category of materials are available for low tensile strength, for static application, for medium fatigue and high fatigue, right? Depending upon fatigue, the grades are available: FDC or TDC or VDC. And if you see for high tensile strength and high fatigue, like this VD silicon chromium, this is, you can say, the best material. This can take care of high fatigue also, and the tensile is also very good. This below table gives the chemical composition you can see, and typically if you see this VD silicon chromium, the carbon is 0.5 to 0.6, silicon 1. So it's a silicon steel, you can see. Silicon is deliberately added. Normally you have seen percentage of silicon is restricted below 0.2, 0.3, right? Even in fractions also. But in case of spring steel, silicon is deliberately added, right? And then manganese, sulfur phosphorus are in restricted quantity, and chromium is there, right? So selection can be done from this table depending upon the fatigue, number of cycles that spring is to encounter. These are some examples of the material that we have seen. For suspension springs where the fatigue is moderate, you can select a TDC or vanadium. And in case of I will read. This is very important. This FD grade is intended for static application required for normal springs. TD grade is intended for medium fatigue levels, such as for clutch spring or brake springs. We can go for TD grades. And the VD grade is intended for use under severe dynamic duties, such as valve springs. So the number of cycles the valve spring has to go, like an engine running at 4,000 RPM. So per second, 80 cycles per second. At that frequency, you need to go for silicon chromium grade of springs. In a clutch application, you know the clutch pressing will be happening maybe 3 minutes after every 3 minutes. So the number of cycles are less. So this can be normal, medium type of carbon steel can be used. Actually, these FD, 2D, VD grades, they have come now. Earlier, it used to be spring grade 1D, 2D, 3D. They were popular. Now the latest grades are which are shown here. And then some like earlier we are seeing the wire, the spring which are in the form of a wire, circular. But some like leaf springs, they are required to be in stretch. For those, these are the classifications. So you can refer this classification for leaf springs, and this table gives a comparison of different grades internationally available for material selection. But you can see that carbon in most of the cases 0.5 to 0.6. Silicon in the silicon grade are 1.4 to 1.8. Normally 0.17, 0.37, 0.17, 0.37. Normally silicon is low, but in high silicon grade spring steel it's very high. And chromium is there. Now we move to cast iron. So wherever possible, I have given the reference of IS, Indian standard or international standard, so that it's easy for you to pick up the material which are commercially available. So one of the intent of this lecture is that so that you know what is the commercially available. You can directly order. So cast iron, you have already studied it at many stages. So wherever the carbon percentage is above 2%, so then we have a cast iron. And in general, it's between 3 to 4.5% carbon in cast iron. And the other notable alloying element is silicon. Silicon is for the flowability. For casting processes, we need flowability. And most of the carbon exists in graphite form in cast iron. And melting temperatures are quite low, 1150 to 1300 degrees centigrade. So the heating, you can say the expenses are low in case of cast iron. Like in a steel, you have to go to 1450, 1500. Here the temperatures are low. Thus easily melted and amenable to casting. And the popular cast iron grades are, one is the grey cast iron, and other one is the nodular or SG iron, which you know by the other name. They are the popular grade. White cast iron or chilled cast iron is also popular in case of camshafts. So this is just a quick picture showing the sand casting process. And if you see the microstructure of cast iron, the graphite carbon flakes will be in the flake form, not in the nodular. It will be linear in the linear dimensional form. So that is why it's weak and brittle under tension. So cast iron application is usually in compression only. But advantages are it can take shape, right? It has damping properties. It is easy to machine, right? It's not expensive to cast. The temperatures are low, and it also has bearing property. At some places, the journal is in direct contact with cast iron. The self-lubricating due to property or due to graphite, due to self-lubricating, we need not add any bimetallic bush or anything. So directly a hardened shaft can run in cast iron. And applications may be engine cylinder blocks in case of tractors and other. In case of cars, we cannot due to weight we cannot use the cast iron. But in case of cars, we require lighter components, so blocks are in cars aluminum only. But in tractors or LCVs or heavy commercial vehicle, the cylinder block is of cast iron. Then cylinder heads, that similarly wherever weight is not a constraint. Cylinder liners are usually cast iron. It may be an aluminium or whatever. The wet liner will be cast iron only. Flywheel, exhaust manifold, transmission cases, brake drum, this. So you can take it like cast iron. If you consider a 2000 kg tractor, so the weight of cast iron components will be around 600 kg. So 25% to 30% is cast iron. So this is like a brake drum. This is a three-wheeler brake drum. This is a car brake. This general application. This is a chemical composition of FG260. This FG260 is our Indian grade. Indian grades are like FG200, FG260, FG300. So 260 defines the tensile. The most popular is FG260. So you can say out of 600 kg, I told you on a tractor, maybe 575 kg is this FG260. Very popular. Earlier, this used the grade, equivalent grade was grade 25. So in Indian grade 25 or current grade is FG260. That's very popular. So carbon is higher and silicon is higher. Right? And another aspect is hardness. Hardness by definition in FG260 allowable as per IS maybe 180 to 230. But if we have hardness above 210, then the machinability becomes an issue, right? So we try to stick to the lower hardness range allowed in this grade. So maybe 185, 195. Above 195, then the productivity will go down. Your tool wear will be more. So we have to restrict the hardness in these ranges. And another thing you see in this sheet, which is actually cast iron tested in a laboratory. The microstructure consists of ferrite and pearlite, right? So ferrite is not good for the you can say for the lower grade castings. Ferrite is there, but in good grade casting, pearlite is desired. So ferrite should be below, like here it's written 4 to 5%. So ferrite will make the structure weaker, and at high temperature it will just break down. The component itself may break down. So desired is to have minimum ferrite and more pearlitic structure. So popular grades, as I told you, FG260, GG25, brake drum, cylinder block, and these. And for grades where strength is not an importance, where only weight is an importance, like a flywheel, there a low grade like FG200, 10, in flywheel or general covers where it's cover only, no functional is coming. So their lower grade FG210 can be used because the main criteria is cost. The normal FG260 price may be in a good foundry 48 to 55 rupees. So, and FG210 may be 43, 44 rupees. Now, as per IS 210, which defines grey cast iron in India, so these are the grades which I mentioned, some of them. FG 150. FG 150 is like almost ungraded, no chemical composition you can assure. So FG 150, 200, 220, 260, as I told you, is the most popular. Then 300, 350, 400, which of course hardly used. Up to 260, it's mostly used. And the equal German grades are GG15, GG20, GG25. GG25 is equal to our FG260. So FG150 has ferritic and paralytic structure, while FG200 and above have paralytic structure in it. So desire to have a paralytic structure. And as I told you, again I'm mentioning that FG, like FG260, 260 is its tensile. So more is the number, more is the tensile property. Now the other popular cast iron is the SGR, spheroidal grey iron. So while making this, magnesium, cerium, Ce is added so that the carbon flakes do not appear, but the graphite appears in spherical form, right? So that it acts as a barrier and the tensile strength improves. So wherever the requirement is higher tensile strength, right, there we go for SGR. And of course it's expensive. And some of the SGRN grades are have tensile properties so good that SGRN in some applications have replaced even the forgings. So applications are pipes, valves, pump bodies, crankshafts. Some of the crankshafts are made in SGRN, which is a high fatigue component. Even that's being used with the SGRN. Roller slides, high strength gears, tractor lift arms, exhaust manifold. Normal manifold in the naturally aspirated engine, in a diesel engine, is FG260 only. But in a turbocharged engine, because the temperatures will go 600, 700, up to 800 also, there the manifolds they make in SGR. Similarly, even turbocharger, turbine. And here are the given SGRN grades as per IS. The most popular being like SG600, SG507, and here also the first value 500, it's the tensile strength, and the second value is the elongation. So we will see in further slide that the elongation in case of SGRN is much more than cast iron. That is why it can be used in applications where the deformation is there or the loading is more. It can absorb the impact load. So like SG507, the tensile is 500 and the elongation is 7%. And similar, the structure is perlite plus ferrite. So you could see in SGRN we never wanted ferrite to be there, but here ferrite is tolerable due to the shape of the graphite. Still we are able to achieve better properties. And some of the components shown here, like crankshaft or angle mounting bracket, which are dynamically loaded components, even they can be made in SGR with the proper grade. Here, just for comparison, grey iron, the flakes are linear, here in the form of nodules. And the popular grades, as I told you, by Indians IS standard 500 by 7 is very popular, and the designation in DIN grades are by GGG, triple G. 2G for if there are 2G only in DIN, that is cast iron. If there are 3G, that's for SGR. And the foundry cupola or induction furnace, first I mentioning here. And molding is hand molding or machine molding for mass production. Machine molding and types of core, CO2 core, shell core. For typical components like cylinder head, cylinder block, where sand allowed after finishing is not there. You need to have a clean surface so that water pump is not damaged or the oil system. Shell core, because it can easily fuse, so you can easily remove the core. So there we use shell core, which makes the casting expensive also. Like SGR and maybe 80 rupees. Right? Here just this sheet I want to show you that in this upper 3 rows are shown cast iron, grade 150, 200, 250, right? And elongation, if you see in cast iron, is hardly 0.8 to 0.3%, very less. Elongation is minimal in cast iron. But when we go for the grades given lower, and if you see grade 500 by 7, up to 7%. So this makes it suitable for parts which are dynamically loaded, as here. Now we go through the aluminium alloys. So aluminium, as it is, will be available or used as sheets or plates or in the casting form, right? In the sheet or plate form, the popular grades are 2024 and T6 is the heat treatment. We will see later on what's the T6 heat treatment, right? And seamless tubes also, bar also, plate also. So here if you see magnesium 1.2 to 1.8%, silicon 0.5%, and copper is there for hardness. In aluminium alloy, copper is there for hardness. So one of the popular is 2024 for plates and sheets, and then 3003. The strength is medium strength wrought aluminum manganese family. Right? So manganese is 1 to 1.5 for strength, and silicon 0.6%. This again for plate and sheets, like a checkered plate here, it's aluminum 3003. Then further strengthened aluminium is 6061, very popular aluminium alloy, right? So it can be available in 6061O, which is the annealed grade, right? Or T4 temper is there, then T6 temper is there. We will see the T6 temper later on. So the tensile properties depend upon the type of heat treatment we do. So while in annealed form the tensile is 125 megapascal, with the T6 tempering this goes up to 300 megapascal. So heat treatment is also very important in aluminium. It may be plates or later on we will see in the casting also. Some of the components which are made in 6061 extruded tubes are there. Then forged forks are there. Even some blocks are machined out of it. So 6061 is very popular. Then another is 7075, further strengthened steel. So this 7075, even the some of the nuts you see, this example is given, the nuts shown here, they are aluminium forged. Usually you must have seen only the steel nuts, right? But the grade and the material properties are so good that forged aluminium nuts are used. for wheel bolts. So this is from 7075. And now we can just very interesting topic is the aluminum alloy casting processes and what are the materials in different casting processes. Sand casting is similar to the what we do in the cast iron, right? The three other important in aluminum is GDC, LPDC, and HPDC. So GDC is gravity die casting, LPDC is low pressure die casting, and HPDC is high pressure die casting, right? And difference is that GDC and LPDC are somewhat similar to sand casting, but the mold is of permanent. It's like, as I told you, hot die steel. It may be H13 hot die steel. The mold is of permanent, right? In sand casting, it's sand only. Right? All right. So GDC and LPDC, and the surface finish we get is better than sand casting. And the molds can be reusable, and the production rate, because the level of automation we can do, the production rates are high as compared to sand casting. And we are also able to give some undercuts, which is not possible even with the core put in a sand casting, because it is retractable die. The die will just open up from the 5 sides. So we can give different internal contours which even are not possible with cores. So GDC process is somewhat similar to, you can say, sand casting. Only permanent molds are there. The pouring you have to do like you do in a sand casting, right? And the mold can be cooled also, so that directional solidification, where we want proper filling, that can cool earlier, and the parts areas which are not important, they can cool later. So the die can have holes and water circulating. So direction solidification is also possible in GDC, which is not there in sand casting. Right? So GDC is almost similar to sand casting, only the mold is permanent. Here similar thing shown here. So these black color inside are cores, and this is the pouring, and this is the gates, and risers are there, and this red color is the casting, which is there. So almost same as a sand casting. And pouring we can do like we do in sand casting. More similar pouring is possible. And the popular materials for gravity die casting is LN6. The properties we can see subsequently. And the components are like intake manifold, brackets, cylinder heads also, cylinder board with casting, cast iron lineup. Some of the cylinder heads are usually GDC only, but some of the cylinder block can also be made where the inner liner is of cast iron. So it is to be made in situ, cast in situ. That cylinder block has to go by GDC only, LPDC is not possible. And LPDC, so in LPDC the process is that the furnace itself is below the die, and the metal pouring is by suction. From the furnace itself, the metal is automatically sent to the bottom of the core, and so the filling process is controlled, and the gating and risering will be minimal because metal is going directly from the bottom gating. So the material wastage in LPDC will be much less as compared to GDC. So the yield will be more. So cycle times are long due to fact that casting is met with a big melt volume by riser to during solidification. So if you see this process, the bottom is shown the furnace, the red color is the melt, right? And through this tube, the middle one, this red color metal is going directly into the mold. right? And for creating positive pressure, the positive pressure is created inside in the, you can say, the area where metal is not there. Some maybe 0.5 bar pressure is there. So due to that pressure, the metal rises and fills. So low pressure. So some 0.5 bar pressure is there for this film. And the typical example is a alloy wheel I have shown you. And this is a whole picture of machine. Like this is the furnace and the die is here. Right? This we are playing the LPG. So other components which are shown is like a cylinder block. Like I said, for cylinder head, GDC is the preferred process. For cylinder block, LPDC is the preferred process. And some cylinder heads are also made. They can be made. And the popular material is AC4B. It's a Japanese material. Here you see the silicon is very helpful, 79%. And earlier I shared that heat treatment we will discuss for aluminium we will discuss later. So the heat treatment of aluminium casting, which is very important from the casting standpoint of view. So either they are available in O annealed stage, or T4 is the solution heat treatment and naturally aged. T5 cooled from annealing temperature shaping process, then specially aged, and T6. T6 is the most popular heat treatment. We will see further what is this, right? So ultimately, heat treatment is for strength only. So we will increase the tensile strength of this material by T6 treatment. So the process is precipitation hardening. First we do solution treatment, and I will show you here. Yeah, if you see that this red portion, the top of the graph, this shows where the aluminium will melt, temperature where the aluminium will melt. So we will keep, after doing the casting, we will put it in a oven so that the temperature is just below the melting point, right? So that all the alloying elements, they get into the solution form, right? And then it's rapidly cooled so that they are not able to go back into that form. They are retained on the grain boundaries. The copper or the silicon, they settle on the grain boundary, and then we do the overaging. Overaging meaning we again heat to around 180 to 200 degrees centigrade, retain it there for 2-3 hours, and then let it cool. So by this whole process, the tensile properties we are able to achieve, even almost we are able to double the tensile properties by this process. Now this slide is very interesting. So as you have seen, there are 4 casting processes in aluminium, right? So from the strength point of view, if you ask me the quality, casting quality point of view, LPDC results in the best kind of tensile property. Then the sand casting, then the gravity die casting, and then HPDC. Otherwise, it has been in our mind that HPDC may be the best process. But HPDC, the casting made from HPDC, we are not able to heat treat. Heat treatable castings are by LPDC and GDC. Right. So, and the other advantage of LPDC, which I shared earlier, the yield is high because the metal pouring is almost automatic. The gating and the risering is minimal, right? And if you compare LPDC and GDC, the initial investment in LPDC may be a bit higher, but over the period, because yield is better, so LPDC may give you cost effectiveness. HPDC, I think it's clear to everyone that we have the 2 dies here, right? And metal pouring after melting is through one side, with the for pressure gating piston is there, and on other side the moving die is there. So after closing the dies, right? The molten metal is moved here and then pressurized. So the pressure can go up to 150 to 100 bar. So that is the high pressure die casting. So best advantage why HPDC in place of LPDC or JDC, then we require wall thickness less. The weight of the component will be less, and the process is totally automatic. The number of components per hour will be 10-20 times more than LPDC JDC. And the parts are not loaded, you can say. The load is less. This advantage is the components cannot be critically loaded, and the HPDC component cannot be heat treated also, right? Because there is no the molds are closed, right? There is no place for any air entrapment to go away in the HPDC process, right? So in HPDC, the air is entrapped on the surface. So microporosity in HPDC are much more as compared to other processes. So if you do heat treatment, the air which is inside the casting, it will come out. So making blisters or pores, so casting itself will become bad. So HPD castings are used without any heat treatment. So this we already discussed. And HPDC, the most popular material is ADC12. So you can say around 80-90% of HPDC castings are made from ADC12, right? And other popular are aluminum, silicon. These two grades are also popular. They are equivalent to ADC12, and usually the per kg rate of a HPDC casting is almost half of LPDC GDC, because ADC12 is usually made from the rejected casting. So all the rejections of other processes, they go into HPDC casting.
What is its chemical composition?
Sorry, I have not added it, but it is almost similar to this. Silicon is around 8%. Sir. It's given here, sir. ADC12 silicon is around 11.8%. And if copper is very high. And in such castings, sir, this is iron. Iron is like a poison in aluminium casting. So iron should not exceed this. Otherwise, the porosity levels, when we do the X-ray, we see the porosity levels. So those we define L1, L2, L3 up to L5. In general automotive, we use porosity level up to L3 only. L4, 5 they will crack. So usually the process is defined this way, and the iron is the culprit in all the cases. Because when we transfer material, the carbon increases during all the components. The aluminum picks up iron from all the places, from the dyes. Iron we have to say. For process selection, as I told you, HPDC, if I start with, it's very expensive. The dye is very expensive. The time to make this dye is also very expensive, right? But if the number of pieces is huge, then, and the component is not critically loaded, then HPDC is to be used. Otherwise, if the casting requires to be heat treated, and the number of pieces are also, you can say, average figure, then go for LPDC. And GDC, if the number is less, we can go for GDC. Property wise, GDC, LPDC, the material property we are able to achieve similar, because both are heat treatable, right? But only thing is LPDC yield is more. So that is the main selection criteria. And surface roughness, of course, SPDC is best. You can see all the on bikes and other. The surface roughness is very good, and the wall thickness up to 1.5 or 0.8 mm possible. maybe 10 minutes.
Because we have to take feedback also.
Achha. Then maybe sir, there is only I will cover one topic, that is plastics, right? Only the main points I will cover. Right? One is this slide, which shows the now the reason for plastics. Wherever a structure is there, where strength is not a criteria, but weight is the criteria. So we go for plastic for weight reduction. The statics is another. So day by day, you can see in cars the amount of plastics is increasing. Inside you see the front console, the bumper, seats, everything plastic is increasing due to the weight factor. Because weight directly relates to fuel consumption and CO2 emission and other emissions also. Right? So we try to make lighter cars so that we are able to meet emission, fuel consumption, because our testing cycle depends on weight of the car, right? So as the weight of car increases, the emission out from vehicle keeps on increasing. So that's the reason more and more plastic is coming. And other reason is so much research going on there. The strength properties are becoming almost similar with the polymers or the fillers additives being added. So, and if you see the most common number one is the PP, polypropylene, and PP used mainly in the our bumper, with some not as a single PP, by adding some ABS or some like rubber like EPDM or some other fillers like talcum powder, right? So with these additives, because the requirement of a bumper is not to break, to take the impact, right? So PP is the preferred material in bumper. And polyurethane, in the seat cushions, polyurethane is used, right? And ABS, all these is dashboard in good vehicles, in you can say the luxury vehicle, they are of ABS, plus all the component you see very well painted or plated, they are with ABS. All the fine finish material, like your rear view mirror finish is very good, knobs, or other areas in the console area of ABS. Then composites, which are polymer plus glass fibers or carbon fiber. And HDP, this fuel tank system, the fuel tank total is HDPE, high density polyethylene. And then polycarbonates, like front lights, they are polycarbonate. And polycarbonates are now also being mixed with ABS or as an alternative, because PC being costly, so it's mixed with ABS some 30-70% ratio to make a cost effective with properties equivalent to polycarbonate. So in this slide you can see the places where all the plastics are coming, right? So if you see by weight, 105 kg in a car constitutes of by plastic only, and the density factor with steel. So percentage wise, maybe it may be 30-40%. Out of 1300 kg of a car, 105 kg is plastic only. And these are given the popular application: bumper, seat, dashboard, and process from the in the refinery, from the barrel of oil what we get. So monomers are made, then in the polymer plants they are made polymers or additives added, right? Then they are made into powder or pellets. From there they are sent to the finishing plants where they create further formulation by adding two polymer, like I said, PC, ABS, or PP plus EPDM, some rubberized. So they are added. Then this powder or pellet forms, they are transported to the ultimate manufacturer who will do the molding, right? This is the life cycle of a plastic manufacturing. These are some of the components. The thermoplastic bumper is there, seat, PU foam is there, some of the applications. So this is like PC and ABS in the front console area, and then ABS for the ORVM, and polycarbonate in the headlight. Right? ABS I told is very popular for internal dashboard components, for wheel cover, even dashboard. PE fuel system I explained you earlier. Then PP for bumper, because it can absorb, and not alone PP but having additives as I told you. It may be PDN, rubber, or calc as a filler. This is just a PVC application I have shown you, but nothing to do with your vehicle. But like PVC we see in our sanitary systems or fuel pipes. So PVC is coming on all these areas. And the reason why PVC, life of this PVC, it runs into 40 years, 45 years. The quality of PVC available, typically in cables and wires we know, the life is huge. And PVC windows we know, and UPVC is unplasticized PVC, because normal for making the PVC soft we are plasticizers, right? But without any plasticizer we call UPVC, and life of that is furthermore. Then PPR also being used now for water pipes. PPR application are there. We are almost 1/3 of normal our GI pipes. PA nylon you know are being used with glass filled fiber for bushings, even or wherever the temperature is higher in the engine hood area, below engine hood area. PA6 or PA66 nylon is also used. Some of the applications of nylon, some gears or bushing, as I told you. And the PA60 is a nylon car, lightweight inner tube. This is the radiator top cover. Earlier it used to be brass. Now nylon is being used. Then polycarbonate, as I told you. Application I show you, like the CDs or this goggles, this meter covers, so they are all coming in PC, polycarbonate. Then the you can say the alloy PC ABS, polycarbonate ABS alloy, plastic alloy. They are used in such application like this trolley bag, some structural components like mobile, even our mobile covers, the thick plastic cover, they are PCABs. Polyurethane, you know, in seats, the soft cushion seat is PU, and this air cleaner filters and see the sealing place. Where the sealing, we have to do the sealing. That is PU. Some only last two slides I will show you. One is the PEEK material. PEEK. It's a very high tensile strength material which is replacing many areas of steel also, like in gears or covers highly loaded. So this is replacing some of the steel also. PEEK. PEEK. The best part is that why this is able to replace, its service temperature goes up to 260 degrees centigrade. Normal plastic is 70-80 degrees. You can take with some fillers to 100 degrees. But peak you can take up to more than 200 also. That's the best part of peak. And lastly, even for gears, earlier these used to be PA nylon polyamides or POM polyacetyl. Now gears, they are available in polyketone. So they done a relative testing with polyketone. This is the fresh gear, and this is after testing. Nothing happened. But earlier, like POM gear, polyacetyl gears were there, they got deteriorated. So now PK is a popular material for such gears, like in oil pump, where the application is that load is not there, but you have to transfer motion. Even in small your the toy cars and helicopters, so they use such gears. So only then composites, you know, in a composite resin is there, then we add carbon fiber or glass fiber, so that the strength is given by the fiber, right? And carbon fiber, you know, with the carbon fiber and resin, the strength can be 3 to 4 times even more than the steel. So slowly and slowly, even carbon fiber reinforced plastics are coming into cars. High-end. Right, sir? Thank you very much. So
Any questions?
we can take some questions.
I have two questions regarding this. One is from the earlier slides. You have mentioned graphite / epoxy. What is epoxy means?
No, epoxy is covered is in this composite only. Where when we make this composite, the base is the epoxy, right? That epoxy can be any thermoset, like a polystyrene, right? So that's the base material, and then we add the glass fiber. Then again a layer of epoxy. So that is, you can say the base material in a CFRF component or GFRF component, glass component.
And second question is from the spring steels. You have mentioned endurance limit. Okay, you can increase the endurance limit by coating or something else.
Coating is detrimental to this. The spring wires are already available, oil hardened and tempered. We do not do any hardening after making it, right? So already the wire is coming like that. Because if you heat, you know the shape is already made. Then at temperature of hardening, 800 to 90 degree, it will lose its the inbuilt strength due to cold working. So spring we cannot do it. We can do the leaf spring heat treatment, but coiled spring we cannot. And any coating is going to, for like electroplating action, is going to deteriorate only the property. Only coating like nitriding, that heat treatment process is beneficial. But other coatings are not good from the strength point of view.
Any query from remote centers? JCDM Sirsa? JCDM Sirsa? Do you have any query or feedback regarding this session? Yeah?
Right now there is no feedback. We will give you after that.
Government Women Polytechnic Jaipur. Government Women Polytechnic Jaipur. Government Women Polytechnic Jaipur.
CV is an
hesitating to speak.
I know.
Jaipur Engineering College Jaipur. Engineering College Jaipur. Sir, do you have any query regarding this session? JEC Jaipur.
No, ma'am, we don't have any question.
Government Engineering College Ajmer.
Okay, we are coming to the last session of the day and probably the last session of the course also. And first, let me thank Dr. Paula. Please come. Now, we are concluding this course, so I have invited Dr. D.S. Pavla, Professor in Mechanical Engineering as well as Head of the Information Management and Coordination Cell. And Rahul also come on this side. And first, I like to thank Mr. P.S. Virdi, who is the Vice President of Continental Engineering Limited, Gurgaon, who has spared his time for this session. And I know that it's very difficult to cover up such a huge topic. And Mr. Virdi is a R&D engineer, and in fact, not only engines, he knows the details of ins and outs of all type of vehicles. And I thank you, and I hope that our interaction continues in future also. And now, starting this validation session, I like to interact with the different centers first. And can you connect me to the Government Polytechnic Ajmer? Government Polytechnic Ajmer, just see it there. You will come this side.
You come in this.
Government Polytechnic Ajmer.
आप दूसरा कर लीजिए कोई बात
नहीं। Dr. Punia, the director of our institute, has also come for this valedictory session. So we have just started.
Please, start.
Just see if you can get connected to this Government Polytechnic Ajmer.
It's Government Engineering College Ajmer.
Government Engineering College. This Government Engineering College Ajmer.
Yes, sir. Government Engineering College Ajmer.
Yeah, we wanted to have the feedback about the course and the different sessions which have been conducted in this course.
So, voice quality is not clear, sir.
Sir,
Hello.
Hello.
Hello. Are you able to listen me?
Yes.
Yes, it's clear now. Voice is clear. Voice is clear. My voice is audible to you.
Yes, sir. It is clear, but the connectivity speed is not much, sir. It comes in a break.
Okay. So just we want to listen from your side that during this 5 days program, what was the learning, how were the contents, how was the delivery, how was the transmission, and what are your suggestions? In fact, if this program is repeated, say in time to come in future, what addition, what suggestions you are giving for this program?
Sir, the program was very well. In fact, the faculty was much benefited and we had faculty from all branches. It was from mechanical, from electrical, electronics, instrumentation, and even computers. And the general feedback is quite good. People appreciated. It was much for the awareness of automobile sector, which is a growing of growing interest to everybody in general. And the course content were very much relevant, related, and we are thankful to NITTR Chandigarh for conducting this program, and we would like to have it such kind of programs in every 3 months, sir.
Every 3 months you would like to have this type of program.
Right, sir.
Wonderful.
Right,
Wonderful.
sir.
Any other participant would like to comment on the program? Any other participant from your institute?
Pardon, sir?
Any other participant would like to comment on this program?
Yes, sir.
Parik बोल रहे हो आप?
Yes, sir. Ankur Parik, sir.
Ankur, how are you?
I am fine, sir. How are you, sir?
Okay, it's very fine, fine, fine. So best wishes.
Right, sir.
Any other participant would like to comment?
Yes, sir. I'm handing over, sir.
Please.
Yes, sir. Contents were very fine, and other than the automobile, the DOE that is also included in this content that was also beneficial for us.
You people know about our O plan, our operation plan. You people are knowing.
Pardon, sir?
Our operation plan, which is available on our web portal, that what program we are conducting in whole year, not only in mechanical, in every branch of engineering, then related to education, pedagogy, then entrepreneurship, then management.
Yes, yes,
you
sir.
Are knowing about operation plan?
Sometime, yes, sir.
Operation plan known to you?
Sir, voice is not clear.
आप लोगों को पता है कि हमारा ऑपरेशन प्लान क्या है? From where this voice is going? This हमारा ऑपरेशन प्लान आप लोगों को पता है, वेबसाइट पे होता है अवेलेबल?
Sir, once we received it in for the calendar, but I think it has not been updated this time, sir. Sir, I request if it can be again sent, so that we will circulate it to all departments, and that will help us joining this program again, sir.
I'm saying there is no need to circulate, there is no need to send you. It is available on our web portal. Just you visit NITTTRCHD.ac.in.
Okay, sir. Okay, sir.
Complete year operation plan is available, and even individual teacher can register online.
Okay, sir. Sir, we will check the website, and we will we will ask the different departments as per their interest. They will the information which is available on website of NITTTR. According to that, they will coordinate and contact NITTR for conducting such programs also.
Okay, very good. Another my suggestion is, you people are appreciating that program was very good, and actually we have tried to have this program interdisciplinary. Interdisciplinary means some contents were related to metal science, some contents were related to filtering, some contents were related to chemical engineering, someone was mechanical engineering, then electrical engineering. Everything was combined here. Can you people conduct one-day program every department? Something was related to electrical engineering, something was related to metal science engineering, something was related to mechanical engineering. Can you conduct a program at your institute at least for one day for the students? Because our final target is our students. Their confidence level has to be built up. And so whatever knowledge you people have gathered, at least department-wise, you please conduct one-day program, and if some expertise is needed from Chandigarh side, we'll extend to you. But whatever learning is there, that has to be connected to students. That's my request to you people.
Right, sir. Right, sir. We'll exactly do it, sir. Thank you, sir.
Okay. Okay. अभी कनेक्टेड क्या है? कन्नड़ साहब इधर देखो, अभी नीचे आवाज आपकी कैसी जा रही है, देखो कैसा वाली देखो।
GCD Sirsa. GCD Sirsa, yes, please.
दूसरे प्रोग्राम मेरा था नहीं, मेरा बढ़िया था नहीं।
Yeah, please comment on the content of the program which you are having.
हेलो,
हाँ, बोलिए.
even when I was good, but the main problem is that there is no technical experience. For example, take the example of CRD. That was very good topic, but other topics was not that much.
दोबारा से बोलो. आप दोबारा से क्या कह रहे हो? अगेन अगेन यू प्लीज रिपीट.
सर, आपने वैसे बहुत बढ़िया था टॉपिक सारे, पर मैं जैसे सीआरडी है उसमें थोड़ा टेक्निकल आपने इन्वॉल्व किया था, वो चीज आपकी बहुत बढ़िया थी एज कम्पेयर टू बाकी अदर टॉपिक्स के. बाकी टॉपिक्स भी गुड थे, बट इतने गुड नहीं थे क्योंकि उसमें टेक्निकल चीज है वो इन्वॉल्व नहीं हुई थी. इसमें टेक्निकल चीज इन्वॉल्व हो जाती है, वो तो थोड़ा बेटर बन जाता है अकॉर्डिंग टू माय पॉइंट.
उसमें टेक्निकल चीजें इन्वॉल्व
नहीं थी. अच्छा, कॉमन रेल वाला इंजेक्शन वाला सिस्टम था. अच्छा, उसमें क्या चाहिए फिर आप लोगों को? जैसे सीआरडीआई दोबारा सुनना हो आपको, व्हाट एग्जैक्टली यू नीड?
सीआरडी वाला था वो बहुत अच्छा था आपका.
अच्छा था, वो अच्छा था, सबसे अच्छा था.
हाँ, सबसे बेस्ट मानो 5 दिनों में तो सबसे बेस्ट वही था.
सीआरडीआई वाला था. अच्छा अच्छा,
टेक्निकल चीज इन्वॉल्व हुई.
अच्छा, टेक्निकल हुई, टेक्निकल नहीं, जनरल चीजें
सबको समझ में आ गया.
ओके, सबको समझ में आ गया इस तरह से.
अंडरस्टैंडिंग के लिए था, सब कुछ था. बाकी जो है ये चीज थोड़ी सी, जैसे आज का टॉपिक था, ये थोड़ा सा बुक से रिलेटेड था, जिसमें बच्चे या अदर इतना ज्यादा इंटरेस्ट नहीं शो करते.
अच्छा अच्छा. और बाकी 4 दिनों में एक तो सीआरडीआई वाला और भी लेक्चर थे ना आपका, एमिशंस पे भी होगा आपका, और भी इंटरनल कंबशन इंजन की एडवांसमेंट्स पे भी था. उनमें
जैसे सर इलेक्ट्रॉनिक्स का था, वो आपको बहुत अच्छा था. मिशन सेशन का वो बहुत अच्छा था. ईसीआर जो था आपका,
हाँ,
वो आपको बहुत अच्छा था टॉपिक.
अच्छा.
यस सर.
चलो, जहाँ टेक्निकल चीजें आ रही थी वो ज्यादा समझ में नहीं आ रही थी, वो यही कह रहे हैं अपन.
यस सर.
चलो, विल टेक केयर, जिससे सभी लोगों को फायदा हो. Got it. Any other participant?
थैंक यू सर.
अरे नहीं बोलना है भाई, इतना पैसा लगाया हमने, नो थैंक यू से काम नहीं चलेगा. यू प्लीज कन्वे टू अस, आस्क अनदर टीचर. ऐसे नहीं, हम 5 दिन से हम लोग बोल रहे हैं, 5 मिनट तो आप लोग भी बोलो. ये बुलाने के लिए तो था आप लोगों को प्रोग्राम, आप लोगों से सुनना है हमें. दूसरे टीचर को बुलाओ.
ओके सर.
Who is coordinator of the program? Who is coordinator of the program?
Manish sir, I think.
Where is Manish?
I don't know sir.
अच्छा, अभी पीछे कौन बैठे हुए हैं आपके
सर? these are fourth year students.
फ्रेंड्स. तो आपके टीचर तो है नहीं सुनने वाले यार, फिर किसके लिए प्रोग्राम था? आप लोग कमियां कैसे निकालोगे, सुना ही नहीं तो.
I will talk to
देखो, आपके टीचर्स नहीं तो हम सर्टिफिकेट भी नहीं देंगे. सर्टिफिकेट नहीं देंगे आप लोगों को. चलो नेक्स्ट.
जयपुर इंजीनियरिंग कॉलेज, जेईसी जयपुर. जेईसी जयपुर.
East Depot. सांगानेर होगा.
गवर्नमेंट विमेन पॉलिटेक्निक सांगानेर जयपुर.
जितेंद्र. हाँ, फीडबैक बताओ इस कोर्स के बारे में।
आप सिस्टम के पास का माइक यूज वायरलेस माइक ऑफ कर दीजिए, क्योंकि वायरलेस माइक से स्पीकर में आवाज जाके दोबारा इको बनती है। तो वायरलेस माइक को ऑफ करके आप लैपटॉप के पास आके बोल लीजिए। वायर माइक है जो स्पीकर से कनेक्टेड है, उसको यूज मत करिए, उसको बोलते रहिए। आप लैपटॉप यूज कर लीजिए।
हेलो।
हाँ, नाउ इट इज वेरी गुड।
सर सुनाई दे रहा है?
हाँ, बिल्कुल साफ।
हाँ सर, गुड आफ्टरनून। फर्स्ट ऑफ ऑल डॉक्टर पूनिया जी, डॉक्टर बलवैद जी एंड डॉक्टर राव साहब, I am Rakesh Yadav, lecturer at Khaitan Polytechnic, Jaipur, presently taking training at Women Polytechnic, Sanganer. Sir, the course content was well designed. Particularly, few topics were more important, like the topic on reduction of friction losses and the topic on ECU, MPFI, and EGR. It is very much beneficial for us, and we will definitely transfer this knowledge to our students. My humble suggestion to NITTTR Chandigarh is kindly conduct few 2 weeks training programs.
Okay.
And this center, Government Women Polytechnic Sanganer, has very good infrastructure. So my second suggestion is kindly allot few more trainings to this center. Mr. Anand has well organized this course at this center. So I am thanking Mr. Anand also for coordinating this course at Women Polytechnic Sanganer. Thank you, NITTTR Chandigarh.
Thank you very much. आनंद से पूछा।
जितेंद्र आनंद, अब आप बताइए कोर्स के बारे में।
Sir, this was my first attempt to coordinate the course. Earlier, I was participant. So I was participating this course as a I was more concerned about coordination of the things. Otherwise, course was very good, and I would like to be allotted more courses.
आपने अटेंड किया 5 दिन?
Yes sir, I attended all 5 days.
अच्छा, अगर यही प्रोग्राम आप NITTTR चंडीगढ़ में आके अटेंड करते और वही आपने सांगानेर पॉलिटेक्निक में अटेंड किया है, व्हाट डिफरेंस यू आर ऑब्जर्विंग?
Yes sir.
आप यहाँ पे आके अटेंड करते, ये फेस टू फेस प्रोग्राम होता और उसी प्रोग्राम को हमने आईसीटी के थ्रू कर दिया है आप लोगों के लिए। आपकी क्या ऑब्जर्वेशन है, क्या फर्क लग रहा है आपको? आपने जो ग्रास्प किया नॉलेज को, हमारे बात जो हुई उसको
Yes sir. हाँ सर, मेरा सबमिशन इसमें ये है कि बिकॉज ऑफ टेक्निकल लिमिटेशन इंटरेक्शन थोड़ा सा कम हो जाता है। जब हम वहां पर आते हैं वो इंटरेक्शन अच्छा होता है। ये बैंडविड्थ की जो लिमिटेशंस है, हमारा जो म्यूचुअल कम्युनिकेशन जब हम करते हैं क्वेश्चंस करने के लिए, समझने, उसमें जो टाइम लैग का गैप है, कई बार वो बात समझने में थोड़ी दिक्कत आती है। तो मेरे ख्याल से वो इंफ्रास्ट्रक्चर की लिमिटेशन से अगर हम कुछ कर सकें अपन, तो उससे ये ज्यादा बेहतर हो जाएगा।
ओके।
क्योंकि कई बार जब हम बात करना चाहते हैं उसमें थोड़ी दिक्कत आती है।
ओके। अदरवाइज आपको जो हमारा वीडियो जो आ रहा था आपके पास, हमारी जो आवाज आ रही थी वो क्लियर थी, साफ थी?
हाँ, ऑडियो में थोड़ी प्रॉब्लम
आती है।
ऑडियो में थोड़ी प्रॉब्लम आती है, तो वो हमारे को मेरे ख्याल से कुछ और इस पे करना पड़ेगा, इस पे थोड़ा सा।
ओके ओके, ऑडियो नहीं करना पड़ेगा, वीडियो इज क्लियर यू आर सेइंग?
वीडियो इज ओके। अदरवाइज
जो पीपीटी आ रही है आपके सामने, जो पीपीटी दिख रही है उसमें जो कंटेंट्स है वो साफ दिख रहे हैं?
बिल्कुल साफ सुथरा था
वो बिल्कुल साफ था।
एंड yesterday one day communication was very good. Yesterday audio was very good. Yesterday morning session. It was very nice.
ओके, चलो गुड, ठीक है ठीक है। और ये सारे वीडियो जो हमने डिलीवर किए हैं, 13 या 14 वीडियोज हैं, ऑल वीडियोज विल बी अवेलेबल ऑन YouTube also.
Yes sir.
Will be putting SS bandwidth, the lecture will be available, SS Dhami will be putting, that lecture will be available. जो experts आए, DS खत्री आए, that video will be in front of you. So अगर कहीं confusion भी रहा है, कहीं आवाज साफ भी नहीं आई, in that video that voice is clear. So आप वापस भी जो है उनको सुन सकते हैं।
वो हम जरूर करेंगे। Thank you very much sir. Yes sir. One participant want to say something.
हाँ, बोलिए बोलिए बोलिए।
हाँ सर, गुड आफ्टरनून सर।
हाँ गुड आफ्टरनून।
हाँ सर, एक कोर्स हम सजेस्ट करना चाहेंगे टेक्सटाइल फाइबर्स का। हाँ, तो ये क्या है, यहाँ पर टेक्सटाइल से रिलेटेड कोर्स है, कॉस्ट्यूम डिजाइन और टेक्सटाइल डिजाइन। तो टेक्सटाइल फाइबर्स का कोर्स की एक नीड है, अगर ये हो सकता है तो प्रोफेसर्स के द्वारा।
अच्छा, तो आप ऐसे करोगे, आप एक 5 दिन का अपना प्रोग्राम टाइम टेबल बना के उसमें कंटेंट्स एक्सपर्ट से डिस्कस करके, टेक्सटाइल के एक्सपर्ट्स आपके पॉलिटेक्निक में भी है, टेक्सटाइल का वहाँ पे कोर्स चल रहा है महिला पॉलिटेक्निक में।
हाँ सर, आप
लोग डिसाइड कर लो, एंड इवन एट जयपुर इटसेल्फ वी कैन कंडक्ट दैट प्रोग्राम।
ठीक है सर, चेतन आनंद सर के सर कर देंगे। ठीक है, इनके पूरे करवा देंगे।
आप एक्सपर्ट से डिस्कस करके, जो एक्सपर्ट वहाँ क्लासेस ले सकते हैं, उनसे डिस्कस करके टॉपिक डिसाइड करके, आपका टाइम फ्रेम डिसाइड करके, एंड यू प्लीज मेल टू अस।
ठीक है सर, ठीक है।
1 minute sir, one more participant want to interact with you.
बोलिए।
Good afternoon sir. Sir, other than these technical courses, we want to cover one more course on stress management, especially here in DWPC Sanganer.
अच्छा, तो कोई बात नहीं, ठीक है। आप उसके लिए अभी हम लोग सितंबर महीने से नीटर चंडीगढ़ आपका राजस्थान में भी आ रहा है। अनदर नीटर विल बी हैविंग दैट इज इन राजस्थान स्पेसिफिकली फॉर द टीचर्स ऑफ द राजस्थान ओनली। And hopefully our first program will start in NIT Jaipur, maybe 15th of September or some appropriate time will decide. So suggestions which you people are giving, please send us in advance, so that the programs which will be starting there, accordingly we can plan. So stress management का हम वहीं पे कर देंगे। आप लोग हमें मेल के थ्रू जो है, जो प्रोग्राम आप कराना चाहते हैं, प्लीज कन्वे टू अस। नीटर चंडीगढ़ इज नाउ विल बी अवेलेबल इन राजस्थान ऑल्सो।
Okay sir, thank you sir.
Thank you sir.
Okay. Move on to next slide.
The Government Polytechnic Ajmer.
हाँ,
Government Polytechnic Ajmer.
ये गवर्नमेंट पॉलिटेक्निक विवेक सक्सेना। हाँ सर, आपकी। हाँ ये
सर, गुड आफ्टरनून सर।
आफ्टरनून।
हाँ सर, वेरी नाइस कोर्स conducted by you, useful to all the peoples and especially for common people also. And जैसा मैंने आप पहले भी रिक्वेस्ट यही करी थी और आपने परमिट किया, these courses should be for all the branches irrespective of mechanical and automobile. और वो मैंने आपसे रिक्वेस्ट की थी, कॉमन ये जो सब्जेक्ट्स हैं इसमें हम किसी ब्रांच को या उसके लिए हम बाहर ना रखें, और फैकल्टी मेंबर्स को सारे ही ब्रांचेस के मेरे फैकल्टी मेंबर्स यहाँ मौजूद रहे। हम सब ने इतना गेन किया। रिसेंट ट्रेंड्स की बात, एक बुक्स में पढ़ना एक अलग बात है, और इंटरेक्शन के थ्रू उस चीज को रिसीव करना वो एक बहुत ही अलग और इम्पोर्टेंट मैटर है सर। आई एम हाईली थैंकफुल टू यू फ्रॉम आवर कॉलेज, एंड होप करता हूँ कि फ्यूचर में भी इस तरह के कोर्सेज हमें मिलते रहे।
बड़े इसमें कुछ टीचर्स जिन्होंने अटेंड किया है ये प्रोग्राम, उनका फीडबैक हमें चाहिए। फीडबैक पॉजिटिवली नेगेटिव, कमियां क्या है इसके अंदर, अच्छाइयां नहीं, हमारी कमियां क्या रही इसके अंदर, दैट एग्जैक्टली वुड लाइक टू।
मेरे हेड मैकेनिकल जो है और मेरे जो कोऑर्डिनेटर हैं उनसे मैं दोनों को मैं देता हूं सर, वो डिस्कस करेंगे आप।
सर गुड आफ्टरनून सर।
हाँ गुड आफ्टरनून।
प्रोग्राम तो सही था, और इसमें कुछ फीडबैक ये है कि एनिमेटेड जो स्लाइड्स हैं, उन स्लाइड्स में जैसे रिटर्न वर्क है, तो उसके अलावा कुछ एनिमेटेड वर्क भी होता, तो जैसे इंजन का वर्किंग है, तो कुछ आजकल लेटेस्ट भी आ गए, तो वो भी इंक्लूड कर लिया जाए तो और भी अच्छा हो जाएगा।
एनिमेटेड चीजें जो एनिमेशन शो होते हैं तो बेटर होता है, आप ये करें
वो चीजें और ऐड हो जाए तो।
वेरी गुड वेरी गुड। और ये एक एनिमेशन की बात हुई, और जो 500 दिनों के जो कंटेंट थे रेलेवेंट थे सारे या नहीं थे? रेलेवेंट थे। आपका जो करिकुलम है पॉलिटेक्निक में आपका ऑटोमोबाइल का, उसमें काम आएगी चीजें?
हाँ सर, काफी पार्ट्स इसमें काम आएंगे,
काफी चीजें काम आ जाएंगी। और ये जो वीडियोस बन गए हैं, ये वीडियोस आप फ्रेंड्स को भी दिखा सकते हैं। ये आपको सारे के सारे वीडियोस यूट्यूब पे अवेलेबल होंगे। आप स्टूडेंट्स को भी बताइए कि ये एक्सपर्ट्स ने, आप नोटिस बोर्ड पे लगाएं ये 14 या 13 सेशंस में से इनको जो ये टॉपिक थे उनके वीडियो जो है इस तरह से 2 तरह के वीडियो यहाँ पे अवेलेबल हैं, वो आप नोटिस बोर्ड पे लगाएं ताकि स्टूडेंट्स भी उसको देखना शुरू करें।
अच्छा, वैसे पंडित जी से बात हो गई है, वो ईमेल पे मेरे एड्रेस पे भेज देंगे, तो वो भी हम स्टूडेंट्स के लिए
क्या भेज देंगे? क्या भेज
लेक्चर्स के जो वीडियोस है
नहीं, लेक्चर आपके यूट्यूब पे पड़े हुए हैं, जस्ट आपको गूगल पे जाना है और आपको जो जिन्होंने लेक्चर लिया है ना उसका नाम लिखना, इमीडिएटली वो वीडियो आपका जो है यूट्यूब पे मिल जाएगा। ठीक है, वहां से स्टूडेंट्स को बताएं। हाँ, ये कोर्स जो हुआ है इस कोर्स का भी नाम देंगे तो आपके टेस्ट जो है वो उसके ऊपर आ जाएंगे।
इधर फीडबैक, कोई और फीडबैक देना चाहता है?
This program is very useful for all of the staff members of Polytechnic. And कुछ इस तरीके का CNC के ऊपर भी कुछ इस तरीके का प्रोग्राम अगर हो सकता है तो हमारे काफी बेनिफिशियल रहेगा। और कुछ लेक्चर्स में ना थोड़ा सा अगर इंग्लिश और हिंदी वाला थोड़ा सा मिक्स करके अगर लैंग्वेज होगा, इंग्लिश वाले में थोड़ा सा अगर वो सामने खड़े होकर मैनुअली अगर देखे तो ठीक रहता है, लेकिन थोड़ा सा अगर हिंदी और इंग्लिश मिक्स हो जाए ना तो थोड़ा सा तो वैसे वीडियो में सुनने में थोड़ा सा आसानी हो जाती है।
हिंदी इंग्लिश दोनों मिक्स अगर दें तो चलो इस चीज का ध्यान रखेंगे। हम तो अभी भी आपसे हिंदी में संवाद कर रहे हैं, कोशिश कर रहे हैं सारी चीजें अच्छी तरह से पहुंचें और हमारे मिल पाए। दैट वी आर ट्राइंग।
ओके,
थैंक यू डियर। नेक्स्ट
RTU कोटा।
RTU कोटा में देख वहाँ तो कम्युनिकेशन की प्रॉब्लम है, उनका डोंगल से चल रहा था।
देखो आप जो है टेक्निकल यूनिवर्सिटी है, उनके पास कनेक्टिविटी नहीं है, जरा डोंगल से
कम्युनिकेशन बड़ी फास्ट हो रही है।
सारी यूनिवर्सिटी तो गवर्नमेंट ऑफ इंडिया दे रही है।
ये नहीं तो ये RTU कोटा
ये तो हो गया,
ये तो जयपुर वाले
हाँ बताइए आपके
देखो नेक्स्ट देखो, फिर कोटा वाले नहीं बैठे।
यही लास्ट है
बस ओके,
अपने यहाँ से
now we can get some feedback from our students also sitting in the studio. Yeah.
Yes, आप इधर आके जैसे बाकी लोग सुने आपकी बात, प्लीज कम टू दिस साइड। यस, यहीं से आवाज भी जाएगी आपकी और लोगों के लिए। इधर आ जाओ।
So the session was really nice, but I would like to suggest some technical things that I think we can improve on. Like we are swapping between the slides and the video. So if we can play that simultaneously, that becomes better for the viewer to understand and interact.
दोबारा बताओ।
So like we are swapping between the slides, na? The person, like I am speaking, so you are transmitting the video. When I am explaining my PPT, so you are transmitting the slide. If we can you split the screen in half and simultaneously you can see me also and the PPT that I am conveying.
बताओ ऐसा मिक्सिंग हो सकता है क्या? मिक्सिंग इज पॉसिबल?
उसकी ना जो ड्रॉबैक है वो है कि जब प्रोजेक्टर प्रोजेक्ट करते हैं ना, हाफ द स्क्रीन जो है हमारी वीडियो ले लेती है, तो जो प्रेजेंटेशन है वो छोटा हो जाता है, तो रीडेबिलिटी नहीं होती।
Small like we have in Skype, the person who is
वीडियो का छोटा सा पिक्चर अपनी छोटी सी आ जाए,
स्मॉल कर सकते हैं, मगर उसके लिए फिर प्रेजेंटेशंस भी उसी हिसाब से पहले बनानी होती है ना, क्योंकि यहाँ पे जो प्रेजेंटर आते हैं वो
उस तरह से नहीं, उसमें पूरा कंटेंट है, उसकी पूरी स्लाइड में कंटेंट है, फिर ला पाना उसको मुश्किल है, दैट स्पेस। अच्छा, ये दिक्कत है, सही है, चलो आई गॉट इट।
या तो ये पहले से प्लान हो जाती है 2-3 हफ्ते कि जो प्रेजेंटर्स आए वो सारे उसी तरह अपनी पीपीटीज बना के लाएं, फिर ये हो सकता है।
बट दैट एडिटिंग
में तो करते ही हैं। जब एडिटिंग करेंगे ना तो उसके अंदर तो ये कर देते हैं, आप जो अलाइन कर देते हैं, पर तभी कर पाते हैं जब आपकी पीपीटी वैसी
पहले मिलनी चाहिए,
पहले मिलनी होती है, अदरवाइज वो नहीं हो पाएगा, उसके अंदर एडिटिंग में भी नहीं हो पाएगा।
बट इसका ऑब्जर्वेशन सर बिल्कुल जैसे स्काइप पे आप करते हो ना, तो दूसरे छोटी पिक्चर आती है, उसी समय नहीं आती रहती है, तो दिस व्हाट ही इज सेइंग कि अगर मेजर पोर्शन पीपीटी का आ रहा है, बीच में वो स्पीकर की फोटो
नहीं, वही किया अपन ने, जैसे यूपी वाले लेक्चर्स वो किए हैं ना अपने, जो रिकॉर्ड किए हैं,
उसमें हमने पीपीटी पहले टीचर से इसी तरह से बनाई कि वहाँ पे स्पेस जो है ना, जहाँ पे कोने पे आपको वीडियो छोड़ के रखा हुआ है, जिसे कंटेंट छुपते नहीं उसके बीच में, ऑलरेडी वी हैव डन, एंड वो सारा का सारा ठीक से जो है बन के आ रहा था। इसमें नहीं, इसमें हम लोग क्या कर रहे हैं कि पीपीटी अलग से आप ट्रांसमिट कर रहे हो या विद वीडियो ट्रांसमिटिंग नाउ?
सर जैसे पीपीटी आ रही है, उसके बाद पीपीटी हट जाती है, पूरी वीडियो आ जाती है, फिर वीडियो हट जाती है, पीपीटी आ जाती है।
पर एक ही चीज आ रही है आपके कैमरा जो है, आपने एक कैमरे से तो आप वो ले रहे हो और पीपीटी आप डायरेक्ट जो है ट्रांसमिट कर रहे हो। पहले हमारी पीपीटी जाने में भी दिक्कत होती थी, पीपीटी क्लियर नहीं जाती थी, तो नाउ पीपीटी इज डायरेक्टली ट्रांसमिटेड, है ना, वो आपके लेक्चर से जुड़ी भी नहीं है, वो तो अलग से ही आप जो है ट्रांसमिट कर रहे हो, और वीडियो सेपरेटली यू आर ट्रांसमिटिंग, ऐसा ही तो कर रहे हैं। चलो,
And so one more thing, if we can use a spotlight instead of this light, because this dims this projector.
That will do. Even heat also, lot of heat is getting created. Just now we have discussed this issue. But you people are in second year, no?
First year.
First year. आप लोगों ने पूरा सुना है, आप लोगों ने काफी लेक्चर सुने हैं। चलो,
okay. Any other feedback from you?
इधर आके so remaining people can see you, they can listen you। आप जो बात कर रहे हो ना, लोगों को भी फायदा होगा आपकी बात। नहीं, कोई बात नहीं, कोई इशू छोटा नहीं होता कभी भी, all are very important।
पीछे बैठे हैं हम तो कई बार क्लियर नहीं आती आवाज, जैसे ऑडियो अगर स्पीकर पीछे,
ये बड़ा नहीं है, ये स्ट्रेंथ आपकी ना, पीछे आवाज नहीं जाती है, जब ये भरा हुआ होता है अपने, तो पीछे आवाज अपनी नहीं जा रही है।
इस वीक जब फ्री होंगे ना, इसे वीडियो एडिटिंग कर रहे थे, तो ये सारे को हम जैसे पहले शिफ्ट किया था ना पीछे, वैसे कर देंगे, एक स्पीकर से लगा देंगे
पीछे, वहाँ पे दे दो, that will do। अब ये बताओ आप लोग कि ये आपने 5 दिन का प्रोग्राम सुना, इस बेसिस पे कोई रिसर्च प्रोजेक्ट आप लोगों का बन सकता है क्या? फॉरगेट अबाउट योर मैन्युफैक्चरिंग एंड स्पेशलाइजेशन, मैं कह रहा हूँ इतनी बातें सुनी आपने, इंटरडिसिप्लिनरी भी थी, क्या एक आध कोई रिसर्च का प्रोजेक्ट भी बना सकते हो क्या? कैन यू डू समथिंग? क्या बना सकते हो बताओ?
Improvements using the open ECU।
ओके, जो क्लोज लूप नहीं होके ओपन, अच्छा ECU को जो है ओपन करके, ओके।
reducing friction by using surface textures, by giving surface textures।
बेनविट साहब वो जो बोल रहे हैं ये बोलेंगे आप, ताकि वो अपने लोग सुने।
He's saying that reducing friction by changing the surface texture of a material.
Yes, sir।
Okay. So I think that Dr. Pandey has taken that session.
Yes, about material।
So based on that session, you are talking. Okay, but we can do that.
चलो, आज आपने जो बेनविट साहब प्रोजेक्ट सोचा था वो इनको जो है फ्लोट करो, उसमें ये क्या कर सकते हैं?
See, I was just having some discussion with our director in the afternoon before coming to this session. And he was floating an idea that since we are conducting for the last 2 years different courses, and particularly on the automobile technology, so why can't we develop some vehicle, okay, which is a unique vehicle based on this electric, petrol, or it's sort of a hybrid vehicle by which can only be used in our own campus, okay. So he has given that idea. In fact, I discussed with him what are his ideas, and I told him that this can be taken on by any student. And definitely, sir, we are sure that we'll give a go to this idea. And in fact, not only from this, the existing batch only, I'll give this project to some of the students, so that when they go out, at least we have some hybrid vehicle on our campus.
Yes, you can come out that existing, the going out batch, they'll be designing their own. You can design your own. There may be 2 ideas, there may be 2 vehicles, there may be 10 vehicles. It hardly matters. You come out with ideas, and we people are very lucky that Mr. Virdi is with us. He is product of this institute, so certainly he is having a lot of affection to this institute. We'll request to him that at least he is staying in Chandigarh for 3 days in a week. So that time we people can utilize his expertise, we can utilize, even we can offer some space here, his office, his research place, everything, and you people can connect to him. In our institute, particularly this thing, no, the leaves which are the tree leaves which are there, enough it is there, and people manually they are carrying from here to there. Lot of efforts are needed. If that type of vehicle you can design, which is even battery, it is being operated by solar panel. So solar panel, battery, the operation of the vehicle, and even maximum speed may be some 20 kilometers per hour. For that purpose, gearbox, everything can be designed, and inside the campus we can use. Now it is being said that 100 cities will be smart cities. Cities will be smart when institutes will be smart. Institutes will be smart when we people are smart. and our actions are smart. So first action which we are taking, our smart action, that inside the institute, the movement of the vehicle, if with the battery, with the solar energy, so without pollution, anything. So that demonstration, that example we would like to create here. So ऐसा कुछ सोचना आप जो शुरू करें, आप मैकेनिकल इंजीनियरिंग के स्टूडेंट्स, इवन यू कैन कोलैबोरेट विद योर इलेक्ट्रॉनिक्स काउंटर पार्ट, यू कैन कोलैबोरेट विद योर इलेक्ट्रिकल इंजीनियरिंग काउंटर पार्ट, एंड एक मॉडल जो है आप बना के लेके आए वर्ल्ड के अंदर बेस्ट स्मॉल साइज जो बनाए हैं, कम कोस्ट के बनाए, कम कोस्ट का मेटेरियल, हाउ इट कैन बी यूटिलाइज। मैसूर में जो इन्फोसिस का कैंपस कभी आप लोगों को देखने का मौका मिले, inside the campus, it's a huge campus, a training center for the graduates who are joining there. It's a training center, huge campus. Inside the campus, no vehicle is permitted. Whatever vehicle they are having, it is electrical vehicles. No pollution from those vehicles. इस तरह का अपन जो है मैकेनिज्म अपने इंस्टीट्यूट में बनाना चाहते हैं. So please do plan, be touching with your head of the department, with your teachers, and my request will be this: please give some time to this institute, particularly motivating these friends. चाहे छोटी सी चीज ही कर दें, कुछ भी कर दें, it should be visible and we should feel proud कि हमारे स्टूडेंट्स ने किया हुआ है. Please.
Yeah, in fact, before I wind up, I let Dr. Pavla. I invite Dr. Pavla to share his views on this particular course.
Director Dr. MP Punia, Mr. Virdi, Dr. Bunwar, Professor Rao, participants at the centers, and students sitting in the studio. We have taken this initiative to introduce programs through ICT. Starting from few courses, we have now 150 plus courses. We have been feeling some difficulty from your side that people were not being sponsored in some of the programs, so we made some of the programs that interdisciplinary the operational plan itself. Director was talking to somebody that whether you are getting, you know about our operational plan, that we call it as O plan. Our O plan is now digital. It is EO plan. So we are not printing O plan. So we are sending it to the colleges and polytechnics through email, and in addition, it is available on our website. And if you want to apply for a program, you have to just click on that program and apply online. That is all. Your application comes to us. So it has been made so simple. We want that more and more people should take benefit from these programs. Coming to ICT programs, we knew that it is difficult for the people to come to NITTTRCHD every time, because you are there, you have your office responsibility, you have your classes also. So we have tried to connect you to our institute, where we invite experts. In this program, you must have seen that very few lectures were taken by our own faculty. All were experts in their field, very senior people, CEOs of the companies who have spent whole life in working in a particular area. Let's say somebody, Professor Kapoor was there, Dr. Kapoor was there, he is working only in filters. So that type of expertise is not available to us and you always. It is not easy. They cannot be made available at your colleges. So we brought them here, we made them interact with you, so that we can take advantage of their expertise. So I will, because we are already running late, I will request you to take maximum benefit of these programs. If you want, there are some programs which are not included in the O plan, but you want it, where more people will benefit. Send us an email. Even if we don't have expertise, we will arrange expertise. We have the provision to arrange expertise. Like we did some programs on textile design in Rajasthan. That was for Rajasthan state only, we did it there. There was a demand for a program on textile engineering, so we will do it. They just send it. The only thing is you have to help us in arranging experts, and we finance it. Our people will be there. They will arrange the program. They will do the logistics also. So you have to come out with your requirements. And another request is that seriously attend the programs. Don't take them as casual. As the director sir was saying, that if somebody is not sitting, we will not give the certificates also. Because certificate is a proof of your attending the program. So I once again request you that be serious in attending the programs, because everything, it is nothing is free. You may be getting it free, otherwise we are putting in money into all these programs. So unless you people take advantage, it is of no use. That means we will be wasting money then. Any programs you want, please do write to us. And I would like to thank from myself all the experts who have contributed to this program, because they are all experts in their areas. I'd like to thank them for coming here and sharing their knowledge. I once again thank you all for participating in the program. Thank you.
Thank you, Dr. Pavla, for your views on this course. And I'll also now
because if they want to, as you said, do some project.
Mr. Virdi, that Mr. Virdi has got a lot of experience, more than 2 decades of experience in the automobile sector. And he has been working on engines, and not only from the 3-wheeler, 2-wheeler, 4-wheelers, even tractors and heavy vehicles. And he has so much experience that he can talk at length without any PPT or any thing. And he can discuss the design of all these such components. So I request that we kindly share your views on this course, particularly on this course, the way we have conducted, your views about that.
Yes, it is very clear. No?
Thank you, Dr. Saab. I seen the total contents of the program, which almost cover, you can say, the electronics part or the mechanical components or the performance related like CRDI, even the filters were covered. So the content, the whole program covers, you can say, the latest improvements which are practically happening in the industry. So benefit of this is going to be that our faculty which attends these, they take it forward to the students. And further interaction, like we people are from industry, so it can be that we can also take up some students for their MTech programs, or some joint development activities we can also do. And if any further requirement coming, like type of lectures or we make into, we can also tailor-made those for the students, and we can visit even at the sites where they are attending, like Jaipur and other. So we can possibly go there also. And of course this is a very vast field. So as somebody recommended that every 3 months we should have similar courses. So, and another my request to the institute will be that, like, this is a typically related to engines, emission, performance related. We can also do some other areas, like transmission is another very important part of the system. So we can also run a next time course comprising of engines as well as the transmission. That maybe we can call it as a powertrain engineering course. Something like that.
Power drive we can
power drawing, yeah.
Power drive we can say, or
right. And other courses of similar nature can be like a other area R&D where we people are working is the styling. So styling and hydraulics also. So some of these are very typical, and also we can, like a CRDA we covered was a basic course. We can also have a typically automotive electronics course for 2 days. That can also be very useful. And request further will be that if this course is like we are directly relaying to the institutes, if we can also have a provision that the industry people can also, they are able to attend these.
Okay. Yes.
So that will also be useful, because in a one go it's like a refresher course, and some of the topics will be very useful. So it will widen the base, and directly the learnings can be then applied also. So it will be much more of an industry and academic interaction happening, because really the course content has been made in a very effective way, which is useful to the industry also. So my best of luck for the further courses, and we people will like always to support the institutes, because this way, this interaction, maybe the society will benefit from this. That's our intention. Thank you.
Thank you.
Thank you, Mr. Vidhi, for your valuable views on this course. And now, before I formally thank the coordinators and the principals of the colleges, I'll also like my director to share his views also and give his advice to the participants.
Dear Vidhi, Professor Pabla, Professor Benwet, Professor Rao, dear students, our team members. First of all, I'll congratulate Mechanical Engineering Department for organizing such a wonderful program, very useful program, which is very useful for students as well as teachers also, even for industry people. As Vidhi is saying, this program is useful for industry people also. So special efforts which has been or the special pain which has been taken by Mechanical Engineering Department, particularly Professor Dami, Professor Benwet, who are in touch with industries, and even this whole 5 days program which is available with in front of you, it has been designed by industry people only. There was no role from our side. So normally what we are saying, there is a huge difference between academic institutes and industries. Now everything we have given to industry, that it is your area, now you please design, please deliver, and the interaction should be with the teachers, with the students. So that way we are very lucky, and we are fortunate, we are successful also, that industry people has come on the common platform where teachers are sitting, where students are sitting, where facilities are there, connectivity is there, and their views, the happenings in the industries we people could present here. The target of this program is basically to invite researchers here, IT people were here, industry people were here, fundamentals which we are knowing because we are teaching this subject since a long time. So we are knowing this subject, but practically we are poor. Industry people are very strong in practical part, may not be that effective in fundamentals of the engine. Then R&D which is being done in IITs, those people were there. So it was a common platform. How things can be planned and how it can be implemented, that everything has been done here in 5 days. And the target of this program is basically to initiate some spark in the minds of the teachers and students. Earlier what we people were doing just at BTech level, some heat balance sheet we were doing on the engines, and in heat balance sheet we were saying some 30% heat is going in power generation, 30% is with cooling water, some 10% with exhaust, and around 20% in friction, that we were saying. Now in your mind the things are coming, how this 20% can be reduced to 18%, to 17%, to 15%. That's the target, in fact, that how this mind can be make more vibrant. So the small things which are there can be propagated in your mind at this particular juncture in the world. If any person who can improve the efficiency of these internal combustion engine by 1%, suppose normally the maximum efficiency which we are getting, thermal efficiency, is 27-28%, not more than that. Only the heat which you are supplying, only 28% is being utilized for the purpose of useful output. If someone can increase from 28 to 29, I think he'll be the richest person of the world, because in 1% the amount of fuel will be saving, and corresponding to 1% improvement in efficiency, that will be the richest person in the world. So these ideas which has been floated by your experienced person in front of you, and something you people can do for the betterment of the society, it will be a wonderful contribution. So our target was to initiate this spark. Now flame has to be propagated. Whatever you people have learned from here, it has to be implemented. And one idea I have given, there may be thousands of ideas. I said one vehicle we want in the NITTTRCHD. In the same fashion, the institutes which are connected, they can also try to implement those ideas. And in an institute, there may be 100 ideas. Out of 100 ideas, if only one is feasible, that itself is contribution. 99 may be non-functional, but if you are adding those 99 non-functional ideas, it can become again one useful idea. So one already useful out of 99, again one useful idea can become. So this type of innovation has to be. And whatever has been learned by the teachers, finally it has to reach to our students. We people are lagging, particularly in our country, we are lagging in research. Our research is very weak. The mindset has to be changed. Even industry people, just we were discussing yesterday, expert from Delhi was saying we are getting the drawings, we are getting the technology from outside. Just we people are producing here according to that technology. Just we people are coping. That concept, that mindset which we are having, it has to go now. Now India is progressing. We are having a huge pool of talents in the country. They should show that yes, we can do something, we can produce something, we can change something. That mindset has to be. So thank you very much again for particularly the centers who are connected to us. According to your requirements, we'll be arranging the program. But as Professor Pablo was saying, from your side, seriousness has to be. Enough money Government of India is paying. This 5-year plan is basically, it is mission teacher training, and in mission teacher training around 6,000 crores rupees provision has been kept by Government of India. But that benefit has to be taken by you people seriously. If at JDC, the institute which you are saying, JCD, if 20 teachers were registered and if one is sitting, it means it's a corruption. Corruption, it doesn't mean it is directly in terms of money only. Whatever responsibility you people are taken, and if you are not doing, you are a corrupt person. So, and if teachers are corrupt, then certainly students will be. We should become role model, and please don't repeat like this one. I'm requesting head of the department, please don't give any certificate to those teachers who are absent, who are not taking participation. Even 10 rupees of the country is being wasted. It means it is bad name on us. So please take care for this one, and in future also teachers who are attending seriously. Only if 10 teachers are attending seriously, it is our contribution. So best wishes, thank you very much, and special thanks to students who are seriously attending this program. And I think it will be a great addition in their knowledge, in their competency. Thank you very much. And my special thanks to this young team. You people were in between going, coming, some classes you are attending, but they were here only. No? Around 12 hours they were here, and going from here they are editing these videos which are there. So their working is for 18 hours, 19 hours. Just like our Prime Minister is saying, I am working for 18 hours. Why not someone should work 18 hours, not 18 hours. One, you remove at least 8 hours, you please work. That's the dream of our Prime Minister. And these friends, they are working for 18 hours. So we feel proud also. Thank you very much.
Thank you, sir. Thank you for your advice. And definitely we will take care of all these aspects which you have pointed out. And now, before closing this session, I'd like to thank the different coordinators, particularly at the Government Engineering College, Ajmer, Mr. Gidwani and Mr. Parekh. I'm thankful to you that you have coordinated this program at your end. And I've seen their participation was complete for both the 5 days, and all teachers were interested and they were interacting with us. And I'm also thankful to Mr. Jitendra Saxena from Government Women Polytechnic Sanganer, who was coordinating the program at Sanganer. And I'm also thankful to the principal, Mr. Vivek Saxena. In fact, I remember I just made one call to him and he said, sir, we'll be definitely acting as a nodal center for this course. So thank you, Mr. Vivek. And I hope that in future also similar program will be conducting for your center. And I'm also thankful to this Dr. Vikas Bansal and Dr. Lata Gidwani from RTU Kota. Today, in fact, I don't know on what is the reason they are not available. Otherwise, I was having continuous interaction with them, and they were available for this course. And also at other centers whose name I don't know the coordinators, I'm thankful to them that this course has been conducted successfully at these centers. I'd also like to thank the participants who have participated in this course, and thankful to one and all for making this program a success. Thank you.
Chale?